Well, let me say welcome. I want to thank all of you for joining us today. I'm Terrence Hurley, the Department Head for Applied Economics and Ag Education, Communication, and Marketing. I appreciate you joining us today for our announcement of the founding of NatCap TEEMs, which comes from Natural Capital, the Earth Economy Modelers. I'm really excited to see how many people showed up to join us today. And there's also almost as many people online. So this is a great turnout for us. As I work through the RSP list, kind of looking through, very diverse crowd. We have folks from finance, energy, transportation industry. We have both federal and state government agencies represented. We have agricultural research centers, international agricultural research centers represented. I know I'm going to miss people here. University of Minnesota, there's lots of people that are joining us from the University of Minnesota, as well as other universities in the US and internationally. There's a lot that we want to talk about today, so I don't want to take up too much time. From Steve, Justin, Mafara. I do want to thank Dean Burr for joining us today. And did Associate Dean of Research, Melania Saki Salsas, make it? You might be online. I want to thank Dean and Burr for joining us today. I just want to make a couple of comments to help you understand what inspired me to choose to support NatCap's team in the Department of Applied Economics as a new center. And first, Justin, the first time I met Justin was in 2009 when he was a new PhD student. I was director of graduate studies, and it just so happened to turn out I ended up also being his first semester teacher for microeconomic theory. Steve, on the other hand, I've known for over 25 years. We showed up here about the exact same time. I was an assistant professor and he was an endowed professor at Kessler Lampert Chair of Ecological and Environmental Economics. And while our research really hasn't intersected that much during that 25 years, I have had a chance. We taught applied game theory for 10 years together. And then over the last 12 years, we both support the PhD microsequence in the department. And so we interact a lot on that basis. I have followed their work through Natural Capital Project, and also their work connecting with GTAP, the Global Trade Analysis Project. And I followed it with great interest, even though I haven't had a chance to interact with them very much on those projects. My experience with them is really, I have a lot of respect for their reputation. I have a lot of respect for what they're accomplishing. And so I really appreciate their work. But I still didn't have a very good feel for it until I actually became interim department head. Because when you're interim department head, you did put cast in the role of having to do annual performance reviews. And when you do annual performance reviews, you have to dig in a little bit deeper into what exactly people are doing. And it didn't take me long to figure out that interest in their work is global, it's accelerating. All right, there's a lot of people very interested in the work, they're interested in their research, they're interested in the models they're developing, they're interested in the data. What is also clear is that this acceleration, this global acceleration, it will quickly outstrip their current capacity. And I think through development of the center, we hope to be able to build the capacity to meet some of that demand, because it's very important, the contributions they're making towards problems we face in terms of climate change and biodiversity loss. There's also a more selfish reason for me to support this center, and that has to do with the fact that they're really doing cutting edge pioneering work, okay? And this pioneering work is going to attract really talented students. We attract talented students, but we're going to be able to attract more talented students, more talented postdocs, more talented visitors, and more talented faculty. And with that, I'd be, more great people to work with as a department head and as a faculty member. So again, I want to thank you for joining us here today. And I'll stop there and turn the program back over to Steve. Thank you.
Okay. Great. Well, welcome. Thanks all of you for coming, and thanks also those of you online. And if you're online and the sound isn't good or whatever, just let us know. We'll try to fix it. Let's go back to the first slide here. So I'm going to talk a bit about what it is that we're up to. What is this Earth economy modeling? Why is it important? And what do we hope to contribute? What are we contributing and hope to contribute in the future? First, I have to say on a personal note, it was really fun for the last half hour mixing out in the lobby with friends and family from so many different parts of my life. The only other time I sort of felt like this was when I got married. So anyway, it's great to see so many familiar and friendly faces. And also, I hope some of you who don't know, just like at a wedding, you meet them and you become friends. So anyway, so this I'm going to talk at kind of a general level about this Earth economy modeling, and Justin will follow me with some more like how really do we do this. But I want to start out with a very general picture, which is this is, you can tell this is the surface of the Earth. And this slide actually comes from someone you'll hear from later, Carl Folke, who's head of the Stockholm Resilience Center. And he emphasizes the point that we live in the biosphere. And the biosphere is this very thin layer, both above and below the Earth's surface. And this is our home, and this is all we've ever known. And because it's home and because we've been immersed in it, it's easy to take it for granted. But in fact, it is our life support system. And so we need to act as if we're good stewards of our life support system. And to make this point, if any of you have seen The Martian, you will know that life is tough elsewhere in the galaxy or in the universe. And just to kind of summarize this point, this is some work we did. We put out a special issue in the Proceedings of the National Academy of Sciences. Several people in the room were part of this. So Mary Ruckelshaus was part of this. But the basic point here is if we're going to achieve sustainable development that global leaders have signed on to, then we need to both think about how do we meet people's needs, but do this in a way which does not compromise the life support system upon which current and future generations depend. So that's the simple challenge that we're up to. And how have we done so far as a global society? Well, as an economist or trained economist, I'd say, we did spectacularly well in the 20th century on certain aspects of this. If you're interested in GDP growth, income per capita, we did spectacularly well in the 20th century. If you look at human longevity, we did spectacularly well in the 20th century. But this has come at a great cost. So I like to call this sort of the Holocene, which is the geographic or geologic era in which we've been for the last 10,000 years. It's kind of like we assume that, well, the life support system has always been there and it will always be there. But in the 21st century, that's increasingly in question. So this is a graphic from a paper that was in Science, headed up by people in Stockholm, colleagues of Carl Folke, talking about the Anthropocene. And the Anthropocene refers to a new era in which humans are the driving force of change in the biosphere. So this was also a headline on The Economist, Welcome to the Anthropocene. We know some of the characteristics of the Anthropocene, not only rising GDP, but rising CO2 levels in the atmosphere. So this is from Mauna Loa. Many of you know this sort of famous graphic showing changes in carbon dioxide in the global atmosphere. We've seen now the impact that has had on climate change, so rising annual temperatures. So it's really striking that every year since 2015 has been hotter than every year before 2015. And every single month for the last 15 months has been the warmest month for that particular month ever. So we're seeing the effects of this. I'm going to concentrate a little bit more on the other crisis at the global level, which is the biodiversity or nature crisis. So I've been fortunate enough to work with something called IPBES. I'll just say it once, it's a real mouthful. It's the International Science Policy Platform on Biodiversity and Ecosystem Services. Okay, from now on, just IPBES. And in 2019, it was part of something called a global assessment, which was basically taking stock of how are we doing? How's nature doing? And, you know, it's fair to say it really did highlighted for me this Anthropocene. So humans have significantly altered 75% of the land surface. You can see large areas of the ocean have been altered by human activity. Over 85% of wetlands have been lost over the last 200 years. So humans are having a major effect on the biosphere. And again, just as with climate, you put up a lot of greenhouse gases into the atmosphere, you're going to see climate change. Here, if you change land use, water use, hydrological cycles, you're going to see impacts. So this is a figure that was in the IPBES assessment that we're seeing extinction rates 10 to hundreds of times higher than the historical record. Here is a chart showing the cumulative impacts by various taxonomic groups of extinction rates of what we know about. Now, it would be easy to stop there and just say, well, this is, you know, that's great, it's about other species, but this is also about human species, right? So this life support system doesn't only support other species, it supports our well-being. And so part of the report of this global assessment and the part that I played a leading part in was looking at how does this affect human well-being? And this is a very busy chart, but I really only want you to take one major point from it. So what we were tasked with doing was to assess how are these various benefits from nature or ecosystem services or nature's contributions to people, like the things that nature does for us for free typically, how are they doing globally? What are the trends? So in kind of that kind of sickly orange color, they're declining globally over the last 50 years. And that, you know, there are places where it's increasing, but globally on average, it's decreasing. And the light blue is where it's been increasing. So yes, we produce more food, we produce more material goods, but all of the top ones are about important regulatory services, preventing storms from damaging coastlines, thinking about air and water quality, pollinators, pest controls. All of those have shown a decline over the last 50 years. And a more recent summary from IPBES and also IPCC, the Intergovernmental Platform on Climate Change, said climate change and biodiversity loss are two of the most pressing issues of the Anthropocene, and the two are interconnected. Don't take my word for it or IPBES. So this is, I won't read you the quote, but you can read it. A pretty remarkable statement from the UN Secretary General, Antonio Guterres. Humanity is waging war on nature, and this is suicidal, and that it must be the top priority for everyone, everywhere, to make peace with nature. So that's part of what we're trying to fit into. Another kind of exclamation point on this comes actually from a very different source. So this is from the World Economic Forum. They have an annual survey of corporate leaders, and they ask them, what are you most worried about? What are you most worried about in 1 year, 5 years? This is the 10-year threat list from them. And you can see in green, these are all the issues that I've just been talking about. So it's climate change to Earth systems, or critical changes to Earth systems, extreme weather events, biodiversity loss and ecosystem collapse. These are, again, not just bleeding hearts at the university. These are the corporate leaders and saying what they are most worried about going out 10 years. Okay, so with that, what are we doing about it? So I want to talk about what we hope to accomplish with Earth economy modeling and why we think this is a super important lens. Well, if you think about all of that I talked about in the Anthropocene and how we're changing things, these are all coming about from economic activity. So if you want to affect that, if you want to change the trajectory of that, you have to address the economic and financial system. So in one sense, what we're really interested in is changing or reforming the economic and financial system so that they recognize the value of nature, first of all, and then have public and private decision-making reflect the value of nature in their choices, okay? And we hope then to align economic activity with long-term sustainable development so that we supply people with their needs, but we do this in a way that does not undercut the long-term life support system on which we all depend. So again, just to emphasize the importance of why is it, we know that ecologists and other natural scientists are concerned about this. Why economists, and why do economists have a central role to play here, along with ecologists and other natural scientists and other social sciences, by the way. And this is an earlier study called the Millennium Ecosystem Assessment, kind of the forerunner of the global assessment from IPBES. And they laid the groundwork and said, look, ecosystems and biodiversity are essential for human well-being, right? The ecosystem services are nature's contributions to people. Sure, it's important for other species. It's really central to human well-being. And this is their version of that kind of messy chart that I showed you before, kind of equally messy, but hopefully you can see the up arrow or up triangles and the down triangles. So each row is a different ecosystem service or contribution to people. And you can, I think, make out that most of these arrows are downward, right? So again, we're going in the wrong direction on most of these ecosystem services. It's really interesting if you look at it. So I just one day did this and said, well, which are the ones that are increasing and compared to which are the ones that are decreasing? And the ones that are increasing are things like crops, livestock, aquaculture. These are things that people get paid for out of the regular financial economic system, right? So if you have the right set of incentives, yes, you can maintain things. And if you don't have the right incentives, you won't maintain things. So really what we're thinking about here is the following. If we think about all of the things that we could do to invest in nature, to restore nature, to conserve it, to manage it well, there's a lot of investments we could be making. And there are many of them that are societally beneficial to make. So the benefits greater than costs. But right now, there are a lot of them that no one has an incentive to do that. So if you look at what's profitable versus unprofitable, it does not align with what's beneficial for society. So part of what we want to do is provide the set of tools to be able to value this and then get this into decision-making so that we in fact align what is privately profitable, what people have an incentive to do, with what's socially beneficial. Okay. Switch gears just slightly. So we have been part of something called the Natural Capital Project, and you'll hear from Mary Ruckelshaus in a little bit, who's the executive director of the Natural Capital Project. The Natural Capital Project, we are a proud partner of it, but we're a small portion of the bigger project. So you can see University of Minnesota here, Stanford University, the Research Center for Eco-Environment of the Chinese Academy of Sciences, the Stockholm Resilience Center, and also the Bayer Institute of Ecological Economics in Stockholm, World Wildlife Fund, and you'll hear from Becky Chaplin-Kramer in a little bit, who's a lead scientist there, and the Nature Conservancy. So this is the Natural Capital Project larger partnership. This is important because, while I love to think of the Department of Applied Economics and the University of Minnesota as being powerful players, it helps to have powerful friends that can spread the message. So, so we are part of this. So NatCap TEEMs, based here at the University of Minnesota, is part of this larger network. The part that we play in this larger network is emphasizing this interconnection with the economics and financial system with these Earth systems. Because again, that's the way that we think we're going to have to be able to shift the trajectory. So NatCap has a kind of global reach to it. One of the things that NatCap has done is create a model called INVEST for integrated valuation of ecosystem services and trade-offs. We are building on top of that base. We're also incorporating economic models. Justin will talk after me a bit about this some more. We'll hear from Tom Hurdle, who's a distinguished professor at University of Purdue, who's head of something called GTAP, or the Global Trade Analysis Project. We have been working closely with them on integrating these ecosystem models with economic models. Okay, really simple slide. So for those of you who have not taken economics for a long time, this sort of really simple diagram was sort of the picture of, oh, you know, consumers, they buy stuff from producers and they work for producers and they get income in order to buy. And so you get this nice closed loop. But as Justin likes to say, you know, this is capturing a general equilibrium picture of the economy, but it's not general enough. And what we need to be able to do is to embed that economic model in Earth systems model. So that, in a nutshell, is Earth economy modeling. So the arrows coming in, we need to think about what are the resources, what are the benefits, you know, how is it that we depend upon nature? We also need to think about those out arrows from the economy. What are the emissions and impacts that we have? How does that change natural capital? And then therefore change some of those inflows back to us, the benefits. I'm going to give you two very quick examples of some work that we've already done with various partners to illustrate some of this, but Justin's going to do more in greater depth. So this is work called Nature's Frontiers. This was with many of our partners in natural capital, but also with the World Bank. The World Bank was very interested in thinking about how can we manage our resources more efficiently. How can we do better, both for nature and for development, which is, of course, one of their central missions. So, you know, are there ways that we can improve and that the World Bank can provide guidance and recommendations to countries that they work with? So we modestly took on looking at returns. So we looked at various kinds of land uses, so agricultural crop production, grazing, forestry. We looked in this particular thing, we focused on carbon storage, greenhouse gas, so methane as well, and then biodiversity, various metrics of biodiversity. And the question that we were asking is, could you arrange the landscape or land management? Could you do it differently and have what economists would call a Pareto improvement? Now, Pareto improvement is simply that nothing is going down. So you have two goals, like I want to conserve biodiversity and I want farmers to earn more income. Can we do this in a way where I can improve carbon and not have farmers lose any income, or vice versa? So that's what these frontiers show. It's basically we put together the ecosystem models. We put together with economic production models, in this case for crops and grazing and so forth. And then we also used optimization. Peter Hawthorne, who's in this room, kind of was the core of the optimization routines. We did this for 146 countries, basically every country that's of a certain size, larger than Puerto Rico, and for which we had sufficient data to make it. And you can see various patterns here. So just on the top left is Haiti. Haiti is quite inefficient. So the red dot is where we are currently. So when people say, oh, if you want to improve the environment, it's at the cost to poor farmers. Well, not in Haiti, because we can rearrange things on the land. In particular, we can restore natural habitat and have more intensive farming practices on the land that remains in agriculture and do better on both carbon sequestration, also biodiversity, as well as returns to farmers, which is important in a place like Haiti. And you can see various other patterns. So Japan, there's not much more they can do to increase the economic returns, but they could increase their environmental returns. A place like Gabon in Africa has a lot of undeveloped land. They could increase a lot in terms of economics, but there's not too much more room that they can do better on in terms of biodiversity. But for a place like Gabon, it's important to think about how do they develop without losing their biodiversity and carbon. One other that I will talk about is something called gross ecosystem product, or GEP. Now, most people know about GDP, even if you haven't taken economics in decades. So we know gross domestic product is measuring kind of income per capita. What gross ecosystem product is doing is trying to measure the contributions of nature to people. So what's the monetary value of the ecosystem services, the cumulative set of ecosystem services? This is work that we've done again with some of our partners, in this case led by the Chinese Academy of Sciences. You'll hear from Ouyang Zhehun in a video recorded remark later on, but Ouyang has been central in promoting GEP, not only academically doing it, but actually getting the Chinese government to use this. I'll talk a little bit about that in a second. But why GEP? Well, we know that GDP, which is probably the most widely referenced statistic anywhere, and it's because it's useful. It provides an easily understood signal of economic performance. Now, I put narrow here because we know it leaves out a lot. And so the book on the right is written by two Nobel laureates in economics, Joe Stiglitz and Amartya Sen. I felt sorry for Jean-Paul Fatouzzi. He's the third author here, but he does not have a Nobel Prize. Anyway, there is widespread recognition, and this book talks about it, mismeasuring our lives, why GDP isn't sort of the be all and end all. In particular, in our area, we need measures that talk about ecological performance. How are we doing in terms of changing the set of ecosystem services and their contribution? So there's overlap between GEP and GDP. I talked about crop production, for example. Some of the values come from nature, but some of them come from human labor and tractors and other things which are part of the normal economy. So what we're trying to do here is not come up with a totally independent measure. As I say, there's overlap, but to highlight the contributions that nature makes to the economy. So in doing this, there's really 4 steps. In China, we were very fortunate to build on work looking at their natural capital assets. So the lands, the waters, their biodiversity. They've done extensive data collection on all of these. We used our invest models to turn those stocks into flows of ecosystem goods and services. We then valued these. Some are easy, some are very difficult. I could spend a long time, but I won't, talking about that step. And then aggregating these up into GEP, being careful not to double count benefits. Like you can't count pollinators who are contributing to crop production and crop production. That would be counting the same thing twice. We have done this. This is a paper that was in Proceedings of the National Academy of Sciences in 2020. This is for Qinghai province in China. It was really a proof of concept. Yes, we can measure not only material services, which tend to be more straightforward, but these regulatory services. And those are, we have to have combine this with ecological modeling in order to be able to say something about this. It's really interesting right now that China is basically committed to reporting GEP for every province, for every city, for every county throughout China, and to be using this to reward or penalize performance of local officials. So talking about incentives, this is a huge change in incentives in a huge country, which really matters. So we've worked a lot, mostly with sort of the public sector side and governments, but we also increasingly now work with the private sector. So the aforementioned IPBES, I'm a co-chair of something called the Business and Biodiversity Assessment, looking at how is it, what are the dependencies and impacts of business on biodiversity? So, in particular, this assessment is called a methodological assessment, looking at how do we measure these dependencies and impacts. We've also worked with several other groups, one called Biosphere Intelligence, other called Earth Knowledge, who work more with the private sector and really have developed connections there. And then, as I said, work through this IPBES biodiversity and business assessment. So work with the private sector and the public sector are both important. So I want to end here, kind of back to the beginning, which is, why are we so passionate about this? Well, again, our mission really is to integrate this ecological and economic data into these Earth economy models to be able to inform decision-making for sustainable development. Easy thing to put on one slide. It takes a lot of effort by a lot of people to be able to do this well. So with that, I'm going to stop. Thank you for your attention. And I'm going to turn it over now to Justin Johnson, who's my colleague in applied economics. And Justin, as you already heard Terry describe, so he got his degree from our department. I was fortunate enough to be his major advisor. And he not only brings a wealth of economic knowledge, but he is also a really good programmer in dealing with large programs and large data sets. So, Justin, over to you.
Thank you so much, Steve. It's great to see everybody here. Thank you so much for coming. Steve has talked about this question, the frontiers in Earth economy modeling. I want to complement that by talking about some of the specific routes forward in Earth economy modeling. So I hope you're going to see some complementarity here. Let's dive into the details. So we're in the Anthropocene. Now what? I think Steve raised some very good points that we have to worry about planetary boundaries. This is yet another one of those graphs that updates the scary radial diagram showing that we are outside of the safe operating space for humanity. Our question on a practical level, how do we build the navigational tools to keep us within that safe operating space? So that's a simple question, right? Well, let's make it a little harder. I think there's a separate ignored problem in this whole planetary boundaries framework. And that's the point that human behavior and human well-being are also central to this, both in terms of we affect what happens in potentially overshooting these boundaries, but also why do we care about this? Because there's humans living on this planet and we want people to prosper. So we're in the Anthropocene. How can we stay in that safe operating space? But I'd actually express it as the safe and just operating space. Taking language from Kate Rayworth's recent book, is that acknowledges, yes, we should not pass the ecological ceiling or we should worry about those planetary boundaries, but we also need to stay above the social foundation. And so on the inside of this donut-shaped element means that we also need to provide sufficient access to the foundational goods and services, especially in an increasingly polarized world that seems like it is full of tensions. This is ever more important. So the question is, how can we stay in that safe and just operating space? This is a great framework. I love it, but it also drives me a little crazy sometimes because it is not applied enough. It doesn't answer specific questions like what policies should we pursue, or is one approach better than another? And so my contention is that we need detailed models. These are the navigational tools that we've been talking about that will allow us to say, how might we stay within the safe and just space? And this is, from my perspective on the applied angle, this is what Earth economy modeling is. I mean, we are not the first people at all to think about the Earth and the economy being interlinked. There's a huge literature on that. But I would argue that most of the focus up until now has been on the top part of this linkage, on the impacts, thinking about how humans impact the environment. Here in Minnesota, and thanks in a large part due to the work of Steve, we have increasingly focused on this bottom part, that we also need to understand how the economy is dependent on nature. And there's relatively less work done in that area. But these models, so it's already a big scope. They're going to need to cover the whole wide range of human biosphere interactions. And, are there any disciplines that like to think about having a model of everything that has all the different pieces interacting with each other? Economists, we have general equilibrium. It is so general, it encompasses everything except the Earth. And Steve has already hinted at this. To navigate the Anthropocene, we think that we need a more general equilibrium, to use a really awkward sounding phrase, but to say that the general equilibrium of economics is not general enough. Okay, so we've claimed that. What is Earth economy modeling, though? This is still information, and so maybe people might change some of these definitions or boundaries, and that's not really too important. But we're going with the operational definition that it's a global model, so global is important here, model that combines general equilibrium, which just means that all markets, prices, countries, etc., can in principle affect each other. And that will be coupled with a high resolution depiction of the world. Our state variable is going to be very highly resolved. So it's detailed enough to model specific biophysical processes like ecosystem services, but also decision relevant things like landowner decisions. What might this particular parcel of land be best used for? But we're going to combine both of these things in something that has two-way linkages then between ecosystems and economic systems, where we have the impacts and the dependencies calculated endogenously. It's one thing to say that, but it's another thing. We're going to take a line from, I think, the computable general equilibrium world is really focusing on making this detailed enough and connected to real data so that it can help make specific decisions and inform policymakers. So that's our operating definition. We made some progress on this. Last year, we published on the Proceedings of the National Academy of Sciences that investing in nature can improve equity and economic returns. But on a more practical level, the programmer level, this was like our coming out paper for the GTAP Invest model, which now you can see I've expanded our little Earth economy circle to include this. This is very detailed, so I'll walk through 4 elements of this that were necessary to make this all work. Okay, so first research frontier is taking the best models that we could find and increasing the level of detail that they would have about land. It turned out land is not always very well included in a lot of general equilibrium models. Many of them will include it as nothing more than a dollar valued capital stock. But that's pretty far removed from a specific grid cell with plants filtering nutrients before they get into the stream network. So we did a lot of fundamental work there. We took a version and made a new version actually of GTAP AEZ. So GTAP is the Global Trade Analysis project that Tom Hurdle will talk about in a moment and Steve has referenced. And AEZ is one that calculates production in areas that are specific to different agroecological zones. And this lets us say more information about like what type of land, not just the dollar value of land, not even just the hectareage of land, but the quality of land is being used. So the twist that we added is we made endogenous the relationship between increasing prices for things like agriculture, and via a land supply function, we allow land to transition from natural cover into economically used states. And this was critical because previous versions of the models, they allowed different sectors to compete over a fixed amount of land. And that's good, but it didn't answer the questions relevant to things like deforestation, where we have new land coming into economic use. And so we parameterized land supply curves using remote sensing data so that these would be specific to the gridded information we have and thereby specific to each agroecological zone. I'll go fast on this one just to pick up some time, but why? Why use the CGE modeling approach? Frankly, what is it for those who did have econ more than 20 years ago? CGEs are computable in the sense that they're going to be really data focused and need to be able to be solved. But you're going to have a lot of information so that you can say things specific to different industries. Like what does the dairy industry impact feel from a specific policy? A CGE will have the detail necessary to do that. General is just that all of the things are linked. And it's equilibrium, which is just the basics, the good things of econ, like the producers will maximize profits, consumers maximize their utility, and prices adjust so supply equals demand. The reason we need these, though, this is the point I want to make with this, is that when we enter this world that Steve laid out in front of us of big sustainability questions, well, it's not surprising when you have a really big question, like almost every global environmental problem, and the policies you have are also very large, they tend, if not always, have general equilibrium effects. And this means that a lot of previous analyses that haven't come from a general equilibrium perspective have often tended to ignore things like unintended consequences or spillovers. Say protection in one country might just encourage exploitation in another country. And why? It's because prices go up for the thing that you controlled in the first country, and it makes it more profitable in the second. And so we're trying to leverage this general equilibrium space to capture that complexity. Okay, the second research frontier is we need to be able to calculate ecosystem services globally. And so this is drawn from a series of studies. We're currently able to run in the GTAP Invest model 6 different ones for sediment retention, climate retention, pollination of crops, timber provision, coastal protection, and marine fisheries. So some of those are easy, like timber, where there's a price, but some of those are not so easy, like sediment retention or pollination. The thing I want to emphasize here is not ecosystem services, but just that computation at the scale is a really important thing to think about. And so to illustrate why computation and my proclivity for programming and big data, the reason that's relevant here is let's just walk through one example of an ecosystem service. Suppose we have an incredibly simple landscape here. There's going to be 4 grid cells and they're on a hill. And so water is going to flow from the right-hand side to the bottom left-hand side. That's going to be our hydrology model. And we're going to keep track of how much nutrient, or I'll talk about sediment, erosion is going to come off of that cornfield, and how much of it gets captured by the vegetation and the root structure on the downstream grid cells. But we need to do that then so that we calculate what is the actual retention of sediment there. That's value that nature is providing for free. We didn't have to dredge that out of the reservoir. But we consider this for all of the grid cells so that we can keep track of this and ultimately be able to calculate what went to the stream and thereby what was, for instance, the reduction in hydropower potential from a now smaller reservoir. So that's a simple landscape. A little bit more complicated, what we're really calculating for each grid cell is the transport area, hydrologically routed based on the digital elevation map. So we kind of like drop a bit of water and watch where it goes through a pixel of interest, and then also keeping track of its route down towards the stream. And then some real data here. We do that for every pixel on the landscape. And so you can see there the red is the upstream transport area, and then the path that it takes to the stream is blue. And then we're going to repeat that calculation on this map here, which is just a small set of which angle the water flows. And so the color here indicates which degree in 360 degrees is that water flowing. And so that's kind of computationally expensive, you might guess, and it is. And that's where we've benefited a lot from this engagement with the Natural Capital Project, people in this room, Becky Chaplin-Kramer, others who have made some fundamental computational advances that we can now calculate this for some ecosystem services at a global scale. The third frontier is predicting where land use will change. A lot of the ecosystem service models are driven fundamentally by where does deforestation or conversion to cropland or other land use changes happen. And to be able to make a statement about what might happen in the future for global Earth economy functioning, we need to be able to take information and get it down to the scale of biophysical models. And what this means is taking regional results. Our GTAP AEZ model gives us endogenously determined land use change per region, but these regions are really big compared to the size of 10 to 300 meter grid cells that we need to be inputted into our biophysical models. And so the question is, how do we do that? Well, because I only have a short time, I'll just say it's calculated with a spatial convolution machine learning model trained on historical land use changes done. No, there's a whole huge research agenda there and computation efforts to make that work. But that's for a different day. The last one, and this is, I think, I list this one last because it might be the most important, that has the most work to be done here, is how do we then take the results from our biophysical model, like INVEST, and express them as inputs into the economic model. We've done a lot of work on this. That's what was behind our PNAS piece last year. Just to give you a flavor of that, a lot of the things are through changes in production efficiency. So if we lose pollinators, pollinator-dependent crops will be having lower yields. But there's many other ways, like reductions in land available as an input to production, or just straight up shifts in supply and demand for different sectors. Maybe people have changing preferences for beef or something like that. We have the infrastructure to model that. But also direct impact on individual welfare. This actually kind of comes full circle. A lot of the original work in ecosystem services was on the direct impact. People care directly about preserving nature, and they do. Okay, so I'm going to spend the last couple of minutes that I have to say, how do we do this in the context of NatCap TEEMs? As I've been indicating, this draws heavily from the Natural Capital Project and INVEST. And what do they have? So they have a graphical user interface. This is just for one of their models, layered on top of a Python library that allows researchers to directly use it. And usually that's the preferred way once you start doing hundreds of runs. But even deeper, this is all based on, the GitHub repository here is just what I'm showing, but replicable code coupled with curated data sets that can be inputted into this, along with just best open source practices. We'll let anybody, fork our repository, make their own. They can brand it their own thing if they want to and sell it. That's fine too. This scales up our impact. They have a hard time competing with us on price though. But the point is we want to build this community and engage in these best replicable code practices. And this has really enabled engagement to succeed both with research communities and decision makers. What we are known for here is what we are calling the Earth Economy Software Ecosystem. Sometimes we call it our dev stack. But this combines a whole bunch of different software packages that we've created built on top of the Natural Capital Project's code to calculate the different parts of Earth economy modeling. So, we have INVEST and GTAP there in the middle. Those are two well-established libraries of code. But there's other things that needed to be done. You can see, SEALS, that is our land use change model. GTAP is just automated CGE analysis run in parallel, so it can be very fast. As well as some sort of more basic things like how do you do parallel computation of a task tree on spatial data? That's Project Flow, or Hazelbean, which is a bunch of highly optimized spatial algorithms. And so developing these has been behind being able to compute this at the global scale quickly enough. And so for the next steps in Earth economy modeling, to save a little bit of time, I'm just going to mention them briefly and then buy us some time that way. But we can talk more about them over the break and then the reception. The first one is we've already established, I think, that nature matters and nature matters most to low-income countries. But one key challenge is this has been based on comparative static exercises. That means comparing an equilibrium in an initial state with what the equilibrium economy looks like in some future date. That's great, but it doesn't say anything about how does it play out over time. And so we've now just about finished a recursive dynamic formulation of GTAP Invest. This was funded by the World Bank's Changing Wealth of Nations team, and they wanted to calculate policy contingent estimates of inclusive wealth. To do that, we basically had to take our model and think about it in a growth context now. Is now savings become capital in the next period depreciated, which causes growth, and then we're going to calculate that every year. And at each time step, we're also going to calculate ecosystem services, hence the need to be good at computing things quickly. A policy that is increasingly being focused on would be a 30 by 30 policy. This is something that is increasingly becoming even legally mandated commitments, especially in Europe, but to protect biodiversity and carbon storage by drastically increasing the amount of protected land that we have. As economists, the thing that stands out to me is, okay, that's a big policy and you're taking land potentially out of production. What are the opportunity costs of that? And a model like this links it and computes it directly. sort of the takeaways, the preliminary work shows that achieving 30% protection of the Earth has costs that are about equal to how much benefit we could have gotten by protecting our ecosystem services, but that it might be compensated at the global scale. If you look at that top bar, we see low-income countries, yes, they're benefiting from ecosystem services enormously, but even more disproportionately, they're the ones that are affected by the costs of implementing a 30 by 30 policy. Okay, so my last slide. We have an ambitious agenda. I had to go way too fast to cover all that stuff, but that's just my way. We've got GTAP Invest, Nature's Frontiers, GEP, many other things. These are building momentum. And just an example of this momentum is that we've been receiving interest from central banks, a good number of them, and other institutions that essentially want to fund us to do this work. But we haven't had the institutional capacity to say yes to everybody because, and actually Terry said it well, I didn't know he was going to say that, that's a perfect setup, is we just didn't have enough people on the ground. And so the goal of NatCap TEEMs is, and focusing again on the programmatic level, is build up the capacity we have to say yes to organizations that want to do this type of work, build the infrastructure, build the code base to enable future engagements. And hopefully NatCap TEEMs then will help us grow into this role. And so really, that's the perfect segue into what I would like to do next, which is introduce our first hire at NatCap TEEMs. Our new executive director, Famara Dampha, is going to come up. Let's give it a moment. And I believe he will introduce himself. So without further ado, Mark.
Wow. Thank you very much, Justin. Good afternoon to everyone here in the room and also you joining us online. It is indeed my pleasure to welcome you again officially as the new director of NatCap TEEMs. And the fun fact is that today is my first day in this position. I would also like to join Terry to welcome all the heads of department, the dean of CFANS, faculty, staff, students, and our valued partners from industry, government, nonprofits, and the philanthropic organizations. It's true that your presence here today reflects the strong and diverse support that we have already accomplished as we embark on this journey to advance sustainable development goals through innovative research that build and is built on trusted partnership. See, Justin says nature matters more to low-income countries. And I keep thinking, why bringing me to lead this center? Coming from a developing country, I understand why nature matters most to us in terms of our lives and livelihoods. And this is something that we'll take very seriously. But one of the things I would like us to do, just to take stock of what has been said in terms of the mission of NatCap. I would like to ask you to kind of share with me some of the key items in terms of the challenges that have been mentioned by Justin and Steve that NatCap team is positioned to do. So those of you in the audience, if you may, just keywords that you've heard from the presentation that has been delivered so far. I'd like to hear some voices. What are the key challenges that we are positioning ourselves to address? Biodiversity loss.
Justice.
Justice. Producer viability. Planetary boundaries. And what are the solutions? Because this is modeling, right? The art economy modeling. So this is critical because communication and what we hear is very, very important in terms of the work that we want to accomplish. You will notice that NatCap TEEMs from the presentation that has delivered here is best positioned to address what is referred to as the economic invisibility of nature. That our team will produce science that shows that biodiversity is the enabling asset through which all other forms of capital can be produced and maintained. It's true that our ecological footprint globally and in many countries far exceeds nature's biological capacity to produce ecosystem services that benefit society. And this, if we don't reserve, will lead to drastic tipping points that can have devastating impacts on lives and livelihoods of people. So we must recognize the ecological infrastructure and invest in protecting and restoring degraded ecosystems across the world. So what we position to do is that by 2030, NatCap TEEMs will be recognized as a global leader in integrating ecological, economic, and climate data to inform sustainable development goals. The core objectives of NatCap TEEMs, as Justin have already highlighted, one is to build and refine models such as GTAP Invest and produce indicators such as the gross ecosystem product that capture the interaction between the economy and ecosystems. These tools will help governments, private sector organizations, civil society to evaluate trade-offs and core benefits of policy decisions on climate resilience, biodiversity conservation, and economic growth. We are also very interested in establishing and strengthening collaboration with key partners. This includes our international partners, but also local organizations to ensure that our models are accessible and beneficial to developing countries and indigenous communities and other communities that are most vulnerable to climate and biodiversity loss. We intend to expand our research capacity to meet the growing demand for art economy modeling by the public and private sector. To achieve these goals, we are committed to working with partners to develop a sustainable funding model by leveraging grant funding, private sector support, and philanthropic organizations funding to scale our research in a more sustainable manner. We will train and nurture, as Terry said, attract students from all parts of the world to develop expertise in environmental economics, climate and natural resource economics, and position NatCap TEEMs as a hub for innovation and capacity building. And this means that those students and experts will be able to provide technical assistance to developing countries, ensuring equitable representation of global sustainability efforts. And finally, we'll provide findings through open publications, open data portals, and partnerships to broaden the adoption of our models. So that being said, in terms of summarizing what NatCap TEEMs aims to do, allow me now to introduce myself a little bit to you and my interests as a lead scientist in this space. I was actually enjoying my own village life in a small village in the Gambia when the Natural Capital Project was founded some 10 years ago. Growing up in this village in the Gambia, raised by a farmer and a veterinarian, I developed a strong connection to nature. And this connection has inspired me to work as a scientist and to act as a climate change negotiator and lead Natural Capital Accounting World. I've been an inspiring leader prior to my role in NatCap, from being as a former director of administration at the National Disaster Management Agency in the Gambia, to actually winning the Outstanding Grassroots Leadership Award of the President Obama's Young African Leaders Initiative in 2014 as a Mandela Washington Fellow. I live here in Minneapolis with my family, my father, and a son and a husband. And I strongly believe that multilateralism and global solidarity are the key to addressing the twin challenges of climate and biodiversity loss. I'm privileged as a climate change negotiator at the UNFCCC to speak directly to decision makers from around the world acting and advocating for justice, equity, especially for those that are most disproportionately affected by the climate crisis. I'm motivated here today to work with all of you and call you my relatives to invest in nature to halt the climate genocide and the biodiversity extinction. Nearly half of the world's population is considered to be vulnerable to these crises, and climate change remains an existential threat to lives livelihoods and killing over 5 million people each year, particularly in places we consider low income and least developed. In places like Burundi down there, almost 99% of the population is at high risk to climate-related shocks. So as we work to build resilience, we must remember and acknowledge that lives lost to climate disasters matter everywhere. So that's why I bring my expertise and findings of NatCap to the international space on climate diplomacy and negotiations. Adaptation is failing globally and in many parts of the world, while loss and damage grows significantly. And the complexity of developing globally relevant indicators and securing enough funding to support adaptation continues to be a grand challenge of our time. And this is why, over 10 years ago, the UNFCCC established what is known as the Global Goal on Adaptation in the Paris Agreement. And the global goal on adaptation doesn't get enough attention as the mitigation goal because we think that adaptation is very local. But the GGA actually aims to seek and advance our adaptive capacity, build our resilience, and reduce our vulnerability to climate shocks. And more particularly, it has a strong connection to nature and biodiversity. It seeks to protect biodiversity and ecosystems to better provide ecosystem services that have been mentioned here, such as clean water, pollination, carbon sequestration, and storage, for ensuring the well-being of this planet and our people and its people. This goal also helps to safeguard livelihoods of the least developed countries and small island nations that depend on nature and climate-sensitive sectors such as agriculture, forestry, and fisheries. Now, it's important that we understand when it comes to loss and damage, there are economic losses, but also non-economic losses. And the issue of non-economic losses is that we do not currently have enough data or models or approaches to be able to quantify the damage to ecosystem, the damage to nature. So NatCap TEEMs and its partners in the Natural Capital Project can have a significant contribution in helping developing countries and helping the world to quantify the non-economic losses and damages as a result of climate change. So this accounting would be needed and required to access funding from the Loss and Damage Fund. So think of it, we have this Loss and Damage Fund, you can only access it if you can prove that through data or through some form of quantification. And in doing so, there is a global effort to develop biodiversity and ecosystem indicators. And this is part of one of the targets, one of the 11 targets of the Global Goal on Adaptation, also known as the Global Climate Resilience Goal. So one of the targets is to develop biodiversity and climate indicators. And recently, I have been selected by the UNFCCC as an expert to support the mapping and compilation of biodiversity and ecosystem service indicators that aim to address the twin crises as alluded by Steve and Justin. Now, this decision was from COP28 in Dubai, when the UN and the world urges parties and non-party stakeholders, such as academics, to provide data and information on relevant indicators necessary to map the impacts of climate change on ecosystems, biodiversity, and also show how nature-based solutions or ecosystem-based adaptation can help to build resilience. So in 2 weeks' time, we'll be convening an expert meeting in Egypt to actually engage with 77 other experts from around the world that will be working on all of the 11 indicators of the Global Goal on Adaptation. I'm also excited about the work of Natural Capital at a global scale. Many of you may know about the system of environmental and economic accounting at the UN level. And this is a system that aims to support countries in developing what is called natural capital accounts in their own countries. So every country, think of your statistics bureaus should have natural capital accounts established in your country for various types of assets. And we should be able to quantify the value of ecosystem services from various forms of assets. And through support that we've got from INE through its Impact Goals grant, we will be piloting a project to do land accounting in Minnesota, which will be helping to show the value of ecosystem services associated with various land types in Minnesota, including forest, wetlands, and agricultural land, and highlighting its contribution to the Minnesota economy. I would also like to highlight some of the work that I've been engaged in at the level of the World Bank. I've been with the World Bank as a consultant for about 4 years now. And the bank is actually bringing together this idea of climate, nature, and development together into what is referred to as country climate development reports. Supported work in this space in Burundi and in the Gambia. And also to highlight some of the work that we will be doing in the Midwest. I actually started this project is a Midwest CAS funded project, which aims to quantify the value of nature in reducing flood risk in the upper Mississippi Basin. So, and this work actually is informed by previous work that we've done in Burundi, which looks at the impact of climate across Burundi's landscape, but also what is nature's role and the role of nature-based solution in building resilience in Burundi. And as a result of that, this work is now leading to the preparation of almost $100 million to invest in nature-based solution work in Burundi, invest in green jobs and climate-smart agriculture across the most vulnerable collines in Burundi. So that being said, I would stop here and introduce us to question and answer session for the 3 speakers that have delivered their presentation. Thank you very much. Any questions for Justin, Steve, or myself?
So Conrad, this is your day 1. What's day 2? What's next? Like, what's the first thing on your list?
That's a great question. So what we would like to do is to organize ourselves in attracting funding. I think funding is that helps us to scale up as an organization, as a center. And in terms of funding, we have been very successful in attracting grant funding. So funding from NSF, from the World Bank and other organizations, but we will develop a funding model that helps us to attract support from private sector, from donors and philanthropic organizations to be able to do more work than academic scientists that can do the work that is needed. So that would be a top priority for us moving forward. But of course, we have plenty of research work to undertake. Thank you.
It was really nice to meet your team and to hear about what you're doing. I'm here representing the new NSF USDA institute called the Institute for Artificial Intelligence in Climate Land Interactions for Mitigation, Adaptation, Trade-off, and Economy. Justin's a part of that, obviously, and so are many other people here. And we're really interested in working more with, this NatCap TEEMs group on a number of different issues relating to artificial intelligence to help guide decision-making. We're interested in helping develop new AI-guided optimization methods for evaluating trade-offs. And we're just really interested in continuing some collaborations we already have. And my one question is really about the decision-making part of NatCap TEEMs and how you see that going forward. And what tools you already are kind of interested in terms of turning all the data you're generating with your modeling into ways that people can actually use that data to help make their decisions.
Great. Well, first thing I'll say, David, is we would love to work more with you. And
a number of different organizations here. I mean, there's a wealth of talent in this room. There's a wealth of talent across this university and in the state. And as Justin, you said, there's certainly no shortage of things that need to be done in addition. On the specific question of decision making, one thing that we have found, and Mary certainly reconciles knows as well, and as part of the National Capital Project, we have tried to develop projects with, sort of co-develop them with the people whose decisions we're trying to inform. And so, from the very early days of the National Capital Project, we have sort of, I'll give you one example. At the very beginning, we worked with Kamehameha Schools, which is actually the largest landowner in the state of Hawaii and one of the largest landowners. And the question there was they have a lot of land, and how should they be managing their land? They were interested in getting an economic return. They have to fund the schools, but they also were interested in how can they preserve the land for Hawaiian culture, for the ecosystem services. So, it's listening to what their needs are, developing the models and the information along with them in order to be able to help with decisions they have to make. That's where we found the sort of sweet spot. It's easy at a university to just sort of run wild with your modeling, but if you aren't grounded and working with groups, I mean, that's the way we found that is successful in actually getting things out of the laboratory and on the ground.
I have a more in the weeds question, I guess, for Justin. So from our talking a lot about climate adaptation. So to what extent does your modeling take into account how these ecosystem services are changing in an already changing climate? So thinking about forest composition and crop productivity.
Great question. The easy and quick answer is not enough. The way we've done it so far is via different scenarios. And so we take different climate scenarios, and that does directly affect some of our ecosystem services. But the key thing we're missing is some sort of direct connection between the economy and climate. But this actually has got a really clear agenda for us, because a lot of economics, in fact, the biggest part of economics that has had anything to do with nature has been on climate change economics. And so we like to take some of the really good work that's been done there and create again, fully connected model where economic activity causes climate change, but then use those results more to what you're saying, which is that they could then be inputs in various parts of the model. One way we do it so far is our climate scenarios drive the different dynamic global vegetation models, which are underneath the land use change models. So I know that's a very technical answer, but yeah, that's where we want to go with this, is that climate change will drive land and everything else, including the actual functioning of ecosystem services.
Any other question?
We should probably. I'm gonna go ahead and move forward. What's next on this? Tom.
I should share screen, and if you can
Yeah,
allow me
let's
to turn
do-
on my video. My video monitor is blocked right now.
1 second, we're working on that.
Oh, allow, okay,
There we go.
okay. Before, can you hear us, Tom?
Yep.
Turn this video on too.
Where?
Does he have to turn his video on?
Yeah, if you could turn your video, and maybe I can quickly.
It's
introduce-
blocked right now. I can't turn it on.
Oh,
Top right.
huh?
Top right.
All right here. We'll make you co-host and see if that helps. Are you able to turn it on?
Okay.
Okay,
Looks-
so.
Are you
right,
seeing me?
Let me take a few minutes to introduce our distinguished guest speakers for today. It's indeed an honor and a privilege to have all of them here with us. And first, we're privileged to have Professor Tom Huddle, a distinguished professor of agricultural economics at Purdue University. We are also delighted to have our second guest speaker, Mary Ruckelsworth, who is the executive director of Natural Capital Project at Stanford University. And joining us in person here is Becky Chapin-Kramer. Becky is the Global Biodiversity Lead Scientist for WWF's Global Science Team. So I'll say a few things about Tom before you start, if I may. So Tom is the founder of the Global Trade Analysis Project, GTAP, pioneering initiatives which is uniting over 30,000 researchers worldwide to provide critical insight into global trade, climate, and environmental policies. So Tom's work has earned enormous accolades, including the 2022 Alexandra von Humboldt Research Prize and Purdue Research and Scholarship Distinction Award. Tom is a fellow of the American Association for the Advancement of Sciences, and he holds fellowship in various environmental economic associations globally. His recent research emphasizes food and environmental security, focusing on the effect of climate change and sustainability. In 2017, he established the GLASS project to address global to local sustainability challenges, which later evolved into the NSF funding GlassNet program, a global collaboration for sustainable resource management. So if you could all join me to welcome Professor Tom Huddle to deliver his remarks and provide insight on the determining factors for the success of the GTAP Center. Thank you, Tom.
Thanks, Famara, for that kind introduction, and congratulations to all of you at TEEMs, Famara, on your first day at work, and Steve and Justin for excellent presentations as usual. My remarks, as has been indicated, will focus on GlassNet, GTAP, and the connection to TEEMs. So GlassNet is a network of networks. This is part of the ExcelNet program that NSF started a few years ago. And having done networks, they decided, let's do networks of networks and also make those international. And so that's what this grew out of. And really the first thing I did was to reach out to Steve, and it was really the Natural Capital Project and GTAP that kicked off this 5-year project that's focused on sustainable development goals related to land and water resources. And you can see we've got a dozen networks involved in this, and we're focusing on a good number of the sustainable development goals. And you can go to glassnet.net to find out more about this. So the key theme behind GlassNet is global to global analysis. So it's embedded in everything you've heard so far, especially Justin's presentation. And it makes the point that sustainability research is inherently local. That's why Justin is doing this SEALS effort to bring everything down to 10 meters or 30 meters or a very fine scale. That sediment retention problem, you can't answer that in general for the whole state of Minnesota or the whole US. You have to be very local to do meaningful research. But if you only look at the local, you miss the global forces driving local sustainability stresses. So you need the global framework that Justin was highlighting, the CGE model that covers the world, because developments in China will affect land use in Minnesota. The character of the solutions, of course, will also vary. Stresses and solutions vary by locality. So people were asking about advising on solutions. Well, there are some that are broadly applicable, but many, to have an interest for stakeholders, you need to have local solutions. But these local responses can feed back and have global consequences. Nowhere was that more evident to me than with the US biofuel program, which was originally engineered around environmental farm income and defense national security considerations in the US, but it ended up spilling over to the whole world and had dramatic effects on worldwide land use, environment, and so on. So for all of this, transdisciplinary collaboration is critical. I don't need to highlight that because Steve and Justin have been baked in that for their whole career. I just wanted to give a shout out to Justin in particular and his collaborators at Purdue in the GTAP project for that excellent work he alluded to briefly, but this was really a major effort to identify how these policies implemented at a very local level might affect global economic welfare. And the first thing they had to do was to look at how land use would evolve under a baseline scenario to 2030. And they found that under that baseline scenario, the degradation of natural capital would hurt the global economy and hurt the lowest income countries disproportionately. So that was the first GTAP Invest kind of linkage. Then they explored solutions, and that was a very interesting part of this project as well. And that involved close engagement between Justin and others in the World Bank, thinking about what policies were relevant to be considered. You have public R&D for agriculture, something that Minnesota has contributed to in the past, a very important avenue for this, also payments for ecosystem services, repurposing subsidies in agriculture for that purpose. And those were shown to reverse the story and indeed benefit the lowest income countries most. So a real shout out to Justin and his team involved in that. That was a major advance and really the first set of findings, research findings behind GlassNet. Let me just say a few words about the case from my perspective for NatCap TEEMs. And this comes out of really my work over more than 3 decades with GTAP. It was in 1992 that we established GTAP. And at the time, there were university-based centers working in global trade policy. And there were a lot of public sector institutions, World Bank, OECD, et cetera, doing modeling in this area. But the problem was the university-based centers didn't have sufficient stakeholder engagement, and they ended up withering away and often not being very relevant for policy. And the beautiful public sector effort that was often started would run for 2 or 3 years until the manager changed, until there was a change of government, and they canceled that project. And it happened time and again. In fact, GTAP grew out of an Australian project that was killed after 3 years of hard work. And we basically absorbed a lot of that capacity and began. So just something in the university or just something in the public sector or the NGO sector, that isn't up to the task at hand. So you need something that fuses the two. GTAP, as I said, was founded in 1992, and we established a consortium. So that is one avenue you may consider. The GTAP consortium populates the advisory board. They meet once a week. They ensure continuity of funding, but they also ensure ongoing policy relevance. And the university base for all of this ensures continuity of research. We're still going after more than 30 years, and we're still learning things along the way and improving the database and models. We have long memories. We're elephants in academia, for good, for better, or for worse. That also provides access to students, and this has been very important for the board members who are always keen. There's an excess demand for PhDs in applied economics who can do this kind of work, the kind of work Justin was talking about. And we have expertise in education and capacity building. In the end, that's what it's going to take. You're going to need to build capacity in the countries that are trying to make these decisions. They aren't going to make a tough decision in their home country based on results generated in Minnesota or Purdue. They need to be able to replicate this and do the analysis themselves. So this just shows you a bit of the trajectory of GTAP, and I think TEEMs has totally this potential because it spans a wider range of issues. And it has that local dimension that's so important. But you can see how GTAP's grown, and it's grown across the world. We began this, there was no one involved resident in Africa who would do this kind of analysis. Now there are several thousand. And the database has been key in all of this, and that's crowdsourced through this network. We started with 15 regions, now we have 160, and Africa has been the most important addition there, better coverage in Africa. And you can see the extent of the consortium membership as well. So GTAP's greatly benefited the department and the university, and I just wanted to highlight that for those in the university administration. I understand there's a dean present, for example. This, if you talk to the dean at Purdue, you talk to the VP for research, you even talk to the president at Purdue, this enhanced international profile and publications means a lot to them. Lots of research funding. We've heard about that. You need the capacity to be able to take it on board and mobilize it to fund and supervise the grad students, to bring on board affiliated faculty. We have a large number of affiliated faculty now in the department. High caliber professional staff, that's going to be key. You've got a great start with FAMARA. You're going to need more in the longer run. And as I said, this is a great opportunity for placement of students in the rapidly expanding job market. It's not the academic job market that's expanding for applied economists. It's in these other areas. So I just wanted to call your attention in closing to this working paper. Jay Ackridge, former provost at Purdue University, and I wrote a paper based on GTAP and the Center for Food and Center for Ag and Food Business that he established at Purdue, and we reflected on what it takes to build and sustain a successful center. And so I refer you to this. You can find it through the GTAP website. It's currently under revision for an education journal, a higher education journal. And with that, I'll wrap it up. Thank you. I'll stop sharing.
So thank you very much, Tom, for those very inspiring words, highlighting the potential that we have to grow. Now I have the pleasure to introduce Mary Ruckelshaus, who is the Executive Director of the Natural Capital Project at Stanford University, where she leads effort to integrate the value of nature in decision-making for sustainable development. Our leadership at the Natural Capital Project is pivotal in advancing global strategies for sustainable resource use and ecosystem protection. With a background in conservation biology and marine ecology, Mary's work focuses on developing tools and models that highlight the importance of ecosystems to human well-being. She has worked with governments, businesses, and communities worldwide to apply these models, helping to balance environmental conservation with economic growth. Mary has contributed to enormous influential publications, with her work regularly appearing in top journals such as in Nature and Science. So please join me, ladies and gentlemen, to welcome the Executive Director of the Natural Capital Project, Mary Ruckelshaus, to deliver her. Thank you.
Thank you, Famara, and it's a pleasure to follow you, Tom, and Steve and Justin and others. I'm really happy to be here again in Minnesota on such a beautiful fall day. And I hope I'll catch us up a little bit in terms of time, but what I wanted to paint a little picture from my perspective as the executive director of this kind of Uber hub partnership that Steve mentioned. So next year, a year from next spring, NatCap will be 20 years old. So as a partnership, we started with this idea, and it was a group of friends. It was those of us who really just liked working together. And it was initially 4 institutions. It was Stanford and the University of Minnesota, paired with the 2 NGOs, the Nature Conservancy and World Wildlife Fund. And soon thereafter, we added our Stockholm institutions and the Chinese Academy of Sciences. So we're now 4 partners with now 400 collaborating institutions. So it's a real network around the world. And the initial idea is what we still work towards, and that is to take the latest, greatest research on nature's contributions to people, benefits of nature to human well-being that Steve and Justin and Famara laid out so well, and get it out of the academy and into practice as fast as we can because of this urgency that Steve laid out really well. And the way that we do that, as Steve mentioned in this discussion earlier in the Q&A, is really by co-creating the data and the science and these software tools with and for the people who are going to use them. So you all know these cases where you could build those beautiful general equilibrium models in your own lab, in your own head. We could build databases, we could build lots of models, and they would be elegant and scientifically rigorous, and we could test them. But they're not likely to drive the transformation that we seek, which is to change policy and change finance. And that comes through engagement directly from the beginning in formulating your research problems with the people who are going to take it and use it. So over time, in this 20 years, we have done 3 things to advance the aims of the partnership. And the first we call demonstrations. And those are those pins on the map Steve showed you. We have about 200 now, where our students, our postdocs, our research scholars have worked with communities, sometimes at a really small scale, sometimes at a national or global scale, to formulate a problem, to listen and learn. What are you trying to solve? What could nature's value information bring to you, and solve a problem in that particular place on a particular policy timeline or a finance timeline. Then we save that lesson in the data and software platform that Justin talked about. So the second big thrust of NatCap's 3 pillars is to make this data and software, as Justin said, open and free. So we decided it was much better to save the lessons from these different demonstrations around the world and let others take it up and keep modifying, keep improving both the research quality, but also the relevance to a new place in a new setting. So over this, again, 20 years, the research has gotten into the software. There's now almost 24 ecosystem service change models and the data to support them, and lots of research scripts. Many of them came from the University of Minnesota. Many came from Stanford and partners and other collaborators around the world. And it's always getting better as fast as people can engage. And the third pillar of our partnership is really what you've also talked about for NatCap teams, and that's to build capacity as we go, and to share the stories, share the cautionary lessons learned, and really elevate these leaders who are implementing this work around the world. And I would say this last pillar is where we feel the most urgent need, as mentioned earlier here today. The demand for this information as the work in the UN and countries, individual communities around the world realize how intertwined human well-being and nature are. The demand is exploding. And luckily, the students and postdocs and faculty want to do this kind of use-inspired research. So we really just need to get those pipelines of experts out into the world and in those decision contexts. So that's where I personally am focusing my effort as the director of this hub partnership, is on this capacity development. And I'll close with a few highlights from Minnesota engagements and why I think this partnership has worked. And the first is, you heard some incredible research and results from Steve and Justin and Famara in what has been created here at University of Minnesota. There is nowhere in the world that has the kind of economic expertise as is embodied in Steve and Justin, and also the patience to take the time to work with people, listen to what their needs are, and actually be more applied, like Justin said. You don't hear that everywhere. I'll give one little story. So the Nature's Frontiers work with the World Bank. It was a big group of us from Stanford, from Minnesota, and elsewhere. We've been working together with the World Bank for maybe 6 months when we realized in a phone call that when our colleagues in the World Bank said agriculture, they didn't just mean crops. They meant livestock and they meant forestry. So all of the economic and earth system models that we had been building globally had just been thinking crops, check, we've got agriculture covered, and we're going to do these other biodiversity and ecosystem service changes. So our team, led by Steve, decided, okay, we're going to take on building a rangeland global model and a forest global model, which did not exist to link with all these other models we had been doing. Becky was very much part of that. Peter's here, Ben is here, many people who sweated, Saleh's here, who sweat through that work. But those little moments where your head sort of explodes at this misunderstanding with collaborators, but we just rolled up our sleeves and made that happen over the next year or so. We added these new models. So that's just one little example of how collaboration throws you curveballs. It takes extra time, but the result in those Nature's Frontiers reports and are now being implemented in many other countries, kind of in this downscaling way around the world, are really why people keep coming back to work with NatCap at Minnesota and in our other hubs. And I'll finally just close with why I think this partnership has worked for 20 years and what I'm really excited about a strong hub with NatCap teams at Minnesota. And it's first and foremost because we started with people we really enjoyed working with. So that's a lot of it, is who do you really like working with, and can you transmit that culture over time? That culture of listening, being humble, and learning from one another is a key part of this kind of collaborative work that we've been really pioneering. You see the research publications, but there's also, as Tom Hurdle just said, there's a lot that we've learned about how to do this kind of work over time and how to build the resources and the network. So we'd love to keep learning together on that. And Walt Whitman said that we contain multitudes. And that really reminds me of the NatCap culture. And I think by that, he meant that not only we internally have many different ways of learning about life and living life, but also we appreciate when we see that in others. We see differences, but also commonness in our humanity. And that really pervades the culture of this overall NatCap partnership. And because of the way that Minnesota, the incredible research scholarship, plus the kind of humans that you are here, I know this will continue. So thanks very much.
Thank you very much, Mary. Relationships matter, and that there is a need for capacity building here and around the world. So thank you very much. Let's now hear from, let's see if we can share your screen.
There's two of them.
This one?
Wait, which one? Is it that one? Yeah, I think that's one you're talking about.
Okay.
Maybe we should have said.
Okay, so it's my pleasure to now introduce global lead scientist of WWF, Becky Chapman-Kramer, who is leading the WWF's global science team, spearheading efforts to advance conservation strategies that promote biodiversity and enhance human well-being. In her role, Becky is very, very collaborative with WWF's networks and external partners to integrate the scientific findings and insights on some of the work that have been presented here into conservation protection. Before joining WWF, Becky was a lead scientist here at the Natural Capital Project here at the Institute of Environment. And her research focused on global ecosystem service assessment and developing tools to highlight the value of nature in decision-making. Becky has also worked with several NGOs, businesses globally on ecosystem assessment and conservation strategies. She has authored influential publications in top journals like Nature and Science, and served as the coordinating lead author for the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. So on that note, I know you could scan the QR code to review a lot of Becky's profile, but I would like us to welcome her to deliver her remarks and provide insight on some of the determining factors of your work and how that links with NatCap teams. Thank you very much.
Thank you, everyone. It's so delightful to be back here. I am raised in Minnesota, so that comment meant a lot to me, Mary, that I think this is the right kind of people to do this kind of work personally. It's really exciting to me to see this launch because it's been a long time coming. And like Famara said, I've had some roots in the NatCap project. And I will say I appreciated that history, Mary, because I think over that time period, over that almost 20 years, we've really seen a sea change of the way people think about these things. I will say that within the NGO community, even just in the very brief last few years, I've seen a change in how they see biodiversity mattering to people and centering people and putting people as like the main foundation of the narrative. As well as I think we're seeing more and more what you've already articulated about business bringing biodiversity in, governments bringing biodiversity in. So these connections are finally being made, which I think is so exciting. And it couldn't come at a better time because, we've already heard a lot about how biodiversity is degrading. WWF has its own kind of work on that topic that I think complements what Steve presented on what IPBES has done. It's not just the species going extinct, but we're seeing declines in abundances and simultaneously shifting distributions of species, both of which compound to change compositions of species, and all of that creates greater extinction risk. But it's not just about the extinctions, because these declines are really what is the death by 1,000 cuts. That we see all of these species around the world declining. This is from WWF's Living Planet report, put out every 2 years. We've been tracking species abundances since the 1970s, and there's been a 69% decline overall in species, even worse off in places like Latin America. And this is the kind of rate that you can't continue to tolerate. It has to end somewhere, and we hope that it doesn't end in a complete crash, right? So what we're trying to push now, this is the way the Living Planet report is coming out actually in 2 weeks, this year's version. And this is from the last version, really trying to waken people up to the fact that the choices we make really shape these outcomes, and we have to do better. The LPR this year will be all about transformative change and the transformation that we need to see, which I think TEEMs is really poised to help deliver on what that pathway looks like. So we have to address the drivers of all of this loss, right? And these are the exact kind of drivers that TEEMs can be looking at in terms of the markets and demand, but also that drive land use change, population change that drive demand, all of these different pressures, climate and pollution. And so those together, I think, then give us this view of how these changes affect both societies, impacts on nature, but also our dependencies. And this is from WWF's Nature of Risk report that came out the same year as the global assessment. These things are all happening together, you know, like-minded. I think that taking this kind of science that is being done at institutions like IFS and the kind of modeling and information that TEEMs is going to produce, places like WWF are really good at putting that into the discourse. And what I wanted to share today was just a little bit about how we're using this information already, how this is playing out in our own work. Because we are seeing the risk already play out in the world, right? Every week there's another headline about a disaster or a supply chain disruption or climate change or you know, some reaction. Even before the pandemic, this was making headlines. So WWF's response is, you know, how are we going to bend this curve of this degradation curve that I just showed you? How do we bring it back to nature positive? You can see on that graph, we have to act now. 2030 is that fulcrum point that, you know, if we don't do this, it's going to be too late. And so one big way that we're working at WWF is through the Science-Based Targets Network, which is it's one of the groups that we're helping co-lead a lot of these science hubs to try to provide an integrated approach to nature action. And just those words are exactly what TEEMs is doing, like really providing that sense of integration of how we get multiple benefits lining up together, multiple dependencies that we have on ecosystems, and how they play out in multiple different ways across society. And so I like this schematic because it kind of shows how this whole ecosystem around groups that need this kind of information interact with the Science Foundation at the roots, as it should be, but even below that, these global goals that we've all agreed to. And so I just want to take a minute to talk about that the Kunming, the Montreal Global Biodiversity Framework that got approved 2 years ago and is up again. The COP is next month. And it's a really ambitious agenda to halt and reverse biodiversity loss for the benefit of people and planet. It's become one of the sort of mainstays for WWF we've organized our work around going up to 2030, because what we're seeing is that it was a great ambitious agenda and not enough action is happening. We really need to see some change faster if we're going to meet this ambitious goal of halting and reversing biodiversity loss. And so the three things that I just wanted to touch on and the way that the science is feeding into them is about mainstreaming biodiversity to address those drivers of loss, integrating nature into climate actions, and aligning public and private with other financial flows to actually unlock the resources needed to make this change. This is the agenda that WWF is pushing at the COP, and I think what I want to show is that it is completely underpinned by the kind of science that TEEMs and NatCap in general is already doing. So on mainstreaming biodiversity, the way you do that, of course, is by showing people how and where our economic values and all sorts of values rely on it. So across integrated landscapes and seascapes, where are these values coming from? And I want to harken back to Justin's work several years ago now that he led with WWF, producing this Global Futures report and showing how much of GDP, you know, trillions of dollars is going to be impacted by change in just a few services, which he already showed. You know, it's just 6 services, a tiny slice of what we actually rely on economically. And it doesn't even account for tipping points, which is a huge concern about how systems could change far more drastically. So I think this was just the beginning, and we're really excited to continue this work, to continue to probe further and be able to really show our business partners, our government partners, to what extent their business as usual actually relies on nature and not undermining it further. And to that end, Steve and Justin and I and others in this room, and including Tom, led a sort of conceptual paper around what we need to do. And I see this as the blueprint for you all, that you're going to fill in all of these red boxes, you know, that we don't do enough to get these biodiversity feedbacks onto ecosystems, or to really understand how these drivers touch down in real places, downscaling them, linking the ecological impacts really convincingly to human well-being the way you're doing with GEP, and disaggregating that to be able to show the effect on different vulnerable populations for equity. and then linking, of course, that all back dynamically in a recursive way, like Dustin was saying, to the overall economy and the next time step of what's going to happen next. Another big thing that we can do that we're talking about at the COP is building synergies and trying to move the conversation forward by understanding where we can find win-wins. But also, I would say we have to understand how we can manage trade-offs. And so this is work that we also led together that identified that we can meet our biodiversity and carbon targets and maintain a lot of local benefits to people in just 44% of land area. But nearly half of those areas that would be such a high priority are also high potential for development across various sectors, especially the renewable sector. So we have to look for the areas where we can build synergies that maybe we haven't thought of yet, that these are not always land uses in competition, but that we can get pollination benefits on solar fields, like work being done here at Minnesota. We can see huge benefits to productivity from allowing some shade for livestock that windmills might provide. That's true. They actually benefit from that. So I think that we need to seek out those opportunities. That's the kind of work that WWF is looking to do through our nature positive energy transition. And it's work I'm really excited to lead with you all to understand where and how that can happen. Another example of those same kind of data sets has been feeding into our biodiversity risk filter that WWF shares with companies as they begin their journey with SBTN to set nature positive targets. You can see a lot of the risks there are actually born from our modeling. So it's like this data going directly into tools supporting decision makers. And then the companies can actually look at where in the world, this is a really huge aha moment for them to see where their supply chain is most at risk, where it causes impacts and where it has risk for dependencies. And then the same sorts of ideas of building synergies, also like helping the climate community realize what an ally nature is for climate and how much nature is dependent, not just for mitigation, but for adaptation. And so this is work that we actually did with TNC, another part of NatCap, that I think has so much more potential to get really practical about what the steps are for implementing agroforestry, reforestation, and avoided forest conversion. We found 35% of the areas suitable in this overall everywhere is possible sense could provide 80% of the benefits to 2 billion people. So that's great from a targeting standpoint. It had no economics in it. So this is a plea to teams to help us get practical about this and actually make this real. Because when it comes down to it, all these ideas are great, but we have a huge funding gap. And this has been said again and again that we have to close the finance gap if we're going to meet any of these targets. And so I just want to bring us back to where Steve kind of started with this Nature Frontiers work that I see as a huge potential for this sort of easy wins that we can align public and private finance just by finding efficiency gains. So if we're on that red dot there in the middle, we can improve biodiversity with no economic loss or vice versa, or do both, go to that point in the middle of the frontier just by aligning our landscapes differently. And that's the kind of work that I think business is really interested in because it doesn't cost them as much, if it's just about changing things that actually is easier on the bottom line. So I think there's huge opportunities for aligning investors like World Bank with private investors. And I think that what I wanted Steve to speak more to, and I hope you still will have a chance to today, is the work that you're doing now to chart that course to the frontier. And Peter Hawthorne in the audience is leading work with that. I just think that's so exciting, and that's the kind of change we need. We have a lot of ambitious ideas of how things could change, but we don't have the practical next steps to say what needs to change where and how much will it cost. So I like to end with this quote because I was, first of all, he's a Midwesterner, so perfect, brilliant person to end with for here. But I think that I used to think about this as like an indictment of how we're getting it wrong, basically, that we're just that we are putting all of our energies into, profitability and nothing into making the world a better place. But now I actually see, I have a huge amount of hope and see just this from the perspective of, wow, what if we get it right? What if we do take the best minds of our generations and apply it to these problems? I'm convinced that absolutely we can unleash our full potential on building a better countryside and seascape and planet. So thank you very much.
Wow. Thank you very much, Becky. So now we have time for a few questions before we have a health break. And then we'll have a panel discussion that I think everybody should try to attend. Few questions for Becky and Mary and Tom. Yeah. Okay, so let's. We have. The video. Oh, the videos, yeah. 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 Let's see.
Okay. Of course, we're academics, and so we like to talk too much, and of course, we're way behind schedule.
Congratulations to you.
Okay, so we have three very short videos, and these are from leaders of the Natural Capital Project who are elsewhere, spread out across the world. So the three, first you'll hear from Gretchen Daly, who's professor at Stanford University, and I think it's fair to say is really, you know, she's quote a co-founder, but the NatCap Natural Capital Project would not exist were it not for Gretchen's leadership and ongoing inspiration. Some of you may know she published a book called Nature Services in 1997, which is really foundational for this whole field. So Gretchen will go first, and then second is Carl Folke, who is he is the director of the Bayer Institute of Ecological Economics of the Royal Swedish Academy of Sciences, and also the co-founder of Stockholm Resilience Center. Again, a world leader. Those of you who have looked at social ecological systems and resilience and all of those things, we owe a debt to Carl. And then the third, and these are all really short, but I really wanted to bring them in. As Mary said, you know, we work with our friends, and fortunately, we have some brilliant friends, and these are three. The third one is Uyan Zihun, who is until recently, he was the center director at the Research Center for Eco-Environment Sciences at the Chinese Academy of Sciences. And he's really the push behind not only GEP that I talked about, but a new system of national parks in China, and their whole system of land use planning that takes ecosystems and natural capital seriously. So with that, I think we can just click? Which click?
Yeah.
Yeah. All right. So here we go. Maybe.
Congratulations to the University of Minnesota and the world. I feel such enormous admiration and excitement over launching NatCap TEEMs. We all know there's no frontier more important today than advancing understanding of Earth's life support systems and their dynamics, together with human, economic, and decision-making systems. And we know also that there's no better bunch in the world to lead this Earth economy modeling and other research and engagement than NatCap TEEMs at Minnesota. So I'm extremely hopeful about really making a difference, both in building a deeper and more solid knowledge foundation, and also in really driving action in the places where we need it most. So with all my heart, deepest congratulations and thanks, and looking forward to engaging together in the years ahead.
Dear Steve and colleagues, warmest congratulations to the opening of the NatCap TEEMs at University of Minnesota. It will be highly exciting and hyper-inspirational to follow the work that you will be doing there, the interface of Earth system dynamics and the development of the economy. This is super important with this type of efforts in those days where things are opening up and we have the opportunity to redirect our future into more sustainable pathways. I look forward to interacting. I look forward to collaborating, and so does the whole Stockholm node of actors here, like the Resilience Center, the Bayer Institute, Anthropocene Laboratory from Global Economic Dynamics Program. Wonderful, hooray, and good luck. Bye-bye.
Dear parents, this is Ao Yang from Beijing. Congratulations to the setup of teams. Assessing ecosystem contribution to human well-being is a long way integrating the bridge between nature and home. A bridge between the business of sustainability and efficiency. This is a great bridge which will lead women to a better understanding of the true nature, true value of nature, and how to make the possible investment in long-term for our next generation. Professor Sripati and his team have did a bunch of fantastic work in this area. They focus on the intersection of ecology and economics, use the economic model to analysis inclusion of natural resources, combine economic tool of GTAP and ecological nature capital tool invest together. All of this work make up the nature frontiers. The set of the Earth's economy models is a milestone of the nature capital research around the world, an important step of a nature capital partnership. As a partner of nature capital and PI of the CIMA, the Center for Ecosystem Variation and Accounting and the Chinese Academic Science, I give my best wish to teams and look for close collaboration between teams and the civil. Which teams and the nature capital partnership have a bright future. Thank you.
Coming to the second segment of the series of talks that we have today. And this one is a panel discussion to be moderated by one of our team members. And my job is to introduce the moderator, and then she will take us through the discussion. So Dr. Colleen Miller is a postdoctoral fellow at the Institute on the Environment. She is a global lead ecologist with a background in ecophysiology and sensory biology. Colleen collaborates frequently with interdisciplinary scientists to model natural systems. He's also working with Becky to develop a living database that combines global insect data sets with remote sensing tools aimed at advancing the understanding of agricultural pest control. She applies data science to make findings accessible to researchers, managers, and decision makers. She's also involved in several other projects that summarizes and estimate the effect of climate change and landscape change on natural systems, such as agricultural pests for a variety of holdings. So please join me to welcome our own postdoc, Dr. Palmino, to moderate this panel discussion. Thank you.
Thank you, Mara. Hi, everyone, and thank you for coming back from the break to join me for this wonderful panel of speakers. I'd like you to welcome me in joining these people because we're going to have a wonderful discussion on the state of sustainability, modeling a science today from a variety of perspectives. First, I'd like to introduce a couple of people that we have online. Dr. Ken Bagstad is a research economist in the USGS Geosciences and Environmental Change Science Center and a co-developer of content for the ARIES project. Ken, if you could just wave your hand. Yep, there he is. Ken is a technical co-lead for the implementation of natural capital accounting in the US government and a contributor to the development of the CAIA 2021 statistical standard and natural capital accounts in other nations. Ken is also a co-developer of ARIES, and he uses artificial intelligence to develop software for environmental decision-making by making models and data interoperable. I'd also like to welcome Dr. Sam Grant, who's the Executive Director of Rainbow Research. Sam, if you could also get a wave. Sam is, as I just said, an Executive Director of Rainbow Research, where he works locally to use his background in participatory action research in environmental and climate justice to help organize, develop, and deliver initiatives that improve human well-being with extensive experience in the local community here in Minnesota. And we also have two panelists here with us in person. First, I'd like to introduce on the far right, Dr. Vipin Kumar, who is a Regents Professor and William Norris Land Grant Chair in Large-Scale Computing, and he's also the Data Science Initiative Director. Vipin applies interest in data mining and high-performance computing to climate and ecosystem research. He's focused on bringing the power of big data and machine learning to understand how humans impact the environment. And finally, I'd like to introduce Dr. Jeff Standish, who's the Senior ESG and Sustainability Consultant for Geosyntech Consultants. Jeff consults on projects to provide sustainable solutions for environmental, social, and government challenges. And he also has years of experience bridging academic research groups and private industry in Minnesota. So thank you all for joining us today. I know I introduced you all just now, but I would like you all to kind of help me break the ice and greet the crowd. If you could each briefly tell us all one thing about yourself that I didn't already mention, but you think that everyone should know. And I'd like to start with Ken.
Thanks. Can everyone hear me?
Yes.
I will just start by saying that I started my career as a botanist, and I still draw great appreciation and inspiration from humanity's relationship with our elder relatives in the plant kingdom.
Thanks, Ken. Sam?
I'll try to copy Ken and say I started my career as a jazz musician. And therefore, I recognize that we're at a moment when extreme critical creative improvisation is very necessary. And I think that is, quite apropos for the beginning of this new initiative in the Department of Applied Economics with TEEMs.
Thanks, Sam. Stephen?
Well, since everybody's talking about the career, so I'm going to say that I started my academic career 42 years ago, and the AI was as hot at that time as it is today. So I can share some ups and downs and the hypes and the promises that the AI can bring to you.
I'll follow suit. Even though I'm a geologist by training, actually pursued professional soccer for a couple of years. It didn't really stick with me because I had to have a day job to play. So, but anyway, that's one thing that folks don't know about me.
All right, thank you all. It's so nice to be able to get to know you all as we enter this conversation. So as we all have been hearing about, NatCap TEEM's mission is to integrate ecological and economic data into Earth economy models in order to inform decision-making for sustainable development. So keeping that mission in mind, I'd like to ask each of you more about your work in sustainable science space, both locally and at a broader spatial scale. And I'd like to first start with Ken, who I know has to get going pretty soon due to our academic timing and also some unforeseen circumstances. So Ken, you are a unique person in that you represent the Aries modeling team, but you've also recently been working quite a bit with NatCap. And I know that a lot of the work that you do tries to find synergies between different groups of environmental economists and modelers, and also different nations trying to model different issues. And this is critical for engaging both local and international organizations in order to guide decision-making. Could you talk about this evolution of roles that you've held over your career and where you think these synergies between different modeling systems or groups could take us? And you're on mute.
Okay, thank you. I'm going to spend just a couple of minutes talking about modeling. And I start with George Box's quote that all models are wrong, but some are useful. And that's something I heard on day one of my first grad level environmental modeling course. And I think it needs to be the North Star for environmental modeling. So there's been some recent research out there showing that scientists pretty universally choose the models that their peers used or those that they learn in grad school and not those best suited to the problem at hand. So this isn't surprising. We're creatures of habit and we're social creatures. We stick with what we know. And at the same time, we of course have this exploding world of big data, increasing velocity, volume, and variety of data that makes it so hard for individuals or even small teams to keep abreast of the latest science. So these two have really, these two trends have informed my interest in making our data and models interoperable and using AI to help navigate and connect that landscape of data and models. And ideally doing it in a federated manner where we, rather than trying to tightly control things, we develop a wider network of scientists better able to collaborate. I think if we could do this, we could deliver higher quality science more quickly and transparently. And that gives us the best chance of informing policies that best bend that curve of nature loss that we all know is so important. This vision, I believe, is completely consistent with one from a 2011 book on mapping ecosystem services that Steve, Gretchen, and other NatCap leadership wrote. And that book suggested over a decade ago that we need tiered ecosystem service models with varying levels of complexity and customization, which we can then apply to different places and questions. And I believe that Aries and NatCap, two different very long-running projects in the ecosystem services space, could be powerful partners to help set the agenda for the global scientific community on ecosystem service modeling. To do this, we need to agree on which vision and principles should guide the modeling community in the next 5 to 10 years. And I'm hopeful that our shared goals and the urgency of reaching them can be more powerful than that very human tendency to create silos, and that we can work together to create and reach for that larger vision.
Thank you, Ken. And I really like what you are talking about and thinking about in your career in terms of increasing communication and collaboration among a variety of groups towards these shared goals. And I think that's something that many of our panelists really think about on a day-to-day basis in their jobs and beyond. And so, for example, Sam, in your career, in your current role, you pursued a lot of projects that have positioned and centered environmental and social justice goals in the local area, but specifically, you've been promoting a lot of approaches that have centered collaboration with communities. And Rainbow Research promotes evidence-based approaches to support solutions in that space and engage communities to work towards some shared goals and work on some shared issues. Can you talk a little bit about how scientists working to model environment, like those at NatCap TEEMs, and those working to model the environment and the economy together, may help assist with those goals and also engage communities in their work?
Thank you, Colleen. And Ken, it's nice to follow you in your comments. I'll begin by going back to something that Famara said in his opening comments. Which is that it's nice that NatCap TEEMs has decided to bring in somebody from a so-called developing economy, or an economy that has been underrepresented, underincluded, underlistened to, as we think about the complex climate future we all share. A lot of my work through Rainbow Research and before as an environmental justice scientist has been making visible what is invisible to scientists and to policymakers who are very siloed and very disconnected from the communities that are most impacted by the diverse environmental and economic crises that we face in human civilization. So I am overjoyed to witness the day one of Famara and the NatCap TEEMs. I've had the pleasure of working with Famara and Steve and Justin, and look forward to opportunities to collaborate with the others who I've got the chance to meet for the first time today. We've got a lot of critical heavy lifting to do. And for me, at the root of that heavy lifting is democratizing open science platforms. Whereas we think about braiding global ecosystem product with local ecosystem product and global domestic product with local economic product, how do we do that in a way where we're privileging and centering the voices and visions of people who are often left out of economic and environmental considerations? And so as I think about the work I'm doing right now and the opportunity to bring that work more comprehensively into partnership with NatCap teams, I'm currently working with FAMARA on a couple of different examinations of flood and drought risk focused on, environmental justice communities across the entire upper Mississippi River Basin and also here in Minnesota, and working with local Black community and a local indigenous nation to do climate resilience planning. And one thing we're missing in these communities is access to this very complex data. And something that the data modelers are missing is direct local knowledge about those, specific and granular details about what's happening in our lived experiences. And I think when we lift up the lived experiences of the people who are most impacted, then our science can be more appropriately fine-tuned to the critical challenges of generating an intercultural, ecological, democratic future that benefits all human beings and all of life. And I think for too long, we have lived in silos and we've lived in divisions of one discipline from another. So for me, at the root of the evolution that I seek is taking the 1994 Charter on Transdisciplinarity and then unifying that with the intercultural orientation developed by the indigenous peoples in South and Central America, and using that in the context of what does an ecological democracy require, and how do we partner scientists with marginalized and most impacted communities to use modeling as a way to iteratively, in a participatory way, shape preferred futures. So that's what I'm hoping for, and that's why I'm here and really excited about this new beginning.
Thank you, Sam. And I have to say, I really resonate with your discussion of breaking down silos between these different groups of people working in the space and beyond, because that's one of the things that drew me to NatCap teams as well. And I think it draws a lot of people to the work that's going on here. As another expert who's been working a lot with the local community, Jeff, as a consulting scientist, you've experienced working locally on a lot of modeling issues, and you've worked in both the private sector and you also have experience in the academic sector, where you've gained experience and perspective on how academic researchers can support local industry, for example. What opportunities do you foresee for the role of ecosystem modeling to inform private sector concerns locally or beyond in the sustainability realm? And what types of problems do you think models are best suited to solve?
Yeah, so in answering that, I'll just give everybody a little bit of context and background. Some of you are familiar with this. I actually was at the university as of 15 months ago. I've worked at INE for a number of years and then MnDrive Environment. And my role in both of those places was connecting researchers like yourselves with external partners that were doing work for their own organization or NGOs, for example. So locally, I think one of the ways that I think the launch of this center and the work that you all are invested in, no pun intended there, can be utilized in Minnesota is simply by awareness, I think, getting out there and being part of community-based conversations. I mean, I've known Sam for a number of years and now have sort of been reconnected with him through his ongoing work and his partnership with all of you launching this center and my involvement in some recent conversations. But I've been aware of Sam's environmental justice work for a number of years and connect with him on a different level through Environmental Initiative, a local nonprofit. That work is happening outside of the natural capital conversation. It's happening for all different reasons. And it's important to bring it all together in different ways. And that happens in different ways when you have different audiences in the room. So how the research and the tools that are being developed are applied to industry problems to provide solutions is a critical part of what I've been thinking about for the past hour and a half, listening to the comments and the work. The research has to happen. The tool development has to happen here at a great university. But you also have to have industry, nonprofits, others that are going to be using those tools in the conversations from the ground up. Because if you're not getting the tools in the hands of folks that are going to be using it with clients, with nation states, with municipalities, then the adoption is going to be really slow. Specifically at Geosyntec, where I work now, I'm actually in a project right now in the state of Missouri, looking at some watershed implementation work around ecosystem services. Not to make it an alphabet soup, but it's referred to as a return on environment study, which is a new term that I just learned a year ago when we put a proposal in to do this work. It is basically ecosystem services, looking at natural resources, current value of those resources for the community benefit. So there is work in the private sector going on in this space, and it's only going to increase, whether you're talking about, ecosystem services for water, for green space, biodiversity, as was talked about a bit by Mary. So there's a definite use case in the private sector for what's going on here.
Thanks, John. And kind of to complement the discussion on what's happening outside the university, I'd like to turn to Vipin and your work that encompasses so many campus institutions and projects, including the AI Climate Institute and other work that you're doing here at the University of Minnesota. And there's some really exciting overlap with NatCap teams that I know your colleague already mentioned earlier during our comments. And for example, AI and machine learning provide capability that's expanded our ability to incorporate different types of data and research recently. For example, I saw you both really vigorously you're nodding your heads when Sam was talking about we need more data, we need local data. Can you talk about what your dream collaboration would be between two different research centers on campus, one that's really focused on data and AI, and one that might be focused on modeling and application?
Absolutely. I think there are tremendous opportunities, as earlier was said. Humans make choices and choices have consequences. And you build models, as Ken said earlier, you build models. All models are wrong, but some are useful. And this is where the tremendous opportunity arises today with the use of AI. And as I mentioned earlier, I have been in this field for almost well over 4 decades, and the AI revolution sort of has been percolating for about 7 decades, going back to the 50s. Believe it or not, computers were very, very slow at that time. And the excitement about AI in the late 80s was just as much as it is today, and yet the capabilities and the expectations are far greater today. And also the hype is also far greater today, right? So I'm trying to sort of balance these two things together. But one of the biggest way the AI has the potential to help many of the questions that people are answering today here is improving the modeling. And the modeling, as we have heard today, is done through process-based models. You try to understand the physics of economics. You build models. You sort of try to figure out if you make different choices, what the action for that, what the consequences would be. But these models are always imperfect realization of the reality. You can never model things perfectly. Even if you try to model at any level of detail, you are bringing in lots of parameters. Those parameters then have to be informed by the data that you have. And the data can vary from local to global. It came up many, many times. You're trying to make decisions at a local scale. If NOAA is trying to make flood forecast for the Great Lakes area, they need data about that area, not about the rest of the country. And this is where the power of the latest advances in machine learning can come and join hands with the process-based modeling. That is, if you look at the lot of the work that's going on in AI, it's all about give me big data and I can just solve your problem. Key example is, of course, you take your phone and point it at any language anywhere in the world, and you can get very good translation in whatever language you want it in. And that process of translating from one language to the other requires almost nothing from the advances that linguists have made over the last 7, 8, 10, 9 decades. So they were able to do it because of a massive amount of data. Now, in many of the scientific problems, including the ones that you are dealing with here, these are scientific, they deal with people, the societies and economic processes, physical processes. You don't have that kind of data. So this new kind of methodology that we're developing in this AI climate that David mentioned earlier is built on the foundation that you have to bring the scientific knowledge and discipline knowledge together with the latest advances in machine learning to solve these problems. And that's the goal of the center, which is, of course, focusing on a subset of the big aim you have here. It's focused largely on trying to figure out what are the practices, management practices that you could adopt to reduce the greenhouse gas emission, maybe even make it negative, put more carbon in the soil, get better yield or better nutrition, and make the crop more resistant to changes in climate. Now, this is, of course, a problem which is very complex from many, many angles, but again, people use models to make these decisions, and those models are imperfect, and this is where the combination of AI and modeling, we call it knowledge-guided machine learning, that comes in to basically use data wherever it's available and improve the modeling and take into places where you have no data or very little data. So this is the power of this new generation of machine learning. I think there's a tremendous scope. There's also a tremendous scope in looking at these Pareto optimal curves as you're trying to optimize, looking at multiple optimization objectives. The entire search space becomes very complex and is one of the main research tasks in this research in the AI climate proposal on how do you come up with intelligent ways of searching this combinatorial space and still get optimal solutions. And third thing that sort of always comes with the use of AI is being able to make your modeling part, if you're happy with your models, how do you make them more efficient computationally? Yeah, if the modeling takes too much time, one of the easiest way people are leveraging AI, machine learning, is to build emulators for these models. They can be done much faster. So I see all of these opportunities.
Wow, thank you, Lisa. So I know that we don't have enough time for all of you, and I had many other questions that I wanted to ask, but unfortunately we do have to wrap up pretty soon here. So instead, I'd like to turn to thinking about their early career professionals that are in the audience today, either online or here with us in person, including myself. So it's a bit of a selfish question. But to end our discussion, I'd like to hear each of you say your call to action to those in the room and beyond who are interested in tackling key questions in sustainability with modeling approaches. And so I'd like to start with you, Jeff.
So later this week, I'm going to be flying out to Albany, but then driving to Southern Vermont to co-present at a New York State Bar Association continuing learning education event. And I'll be talking about ESG, environmental social governance, not just the work within that space, but actual disclosure, ESG disclosure, which in industry is a very hot topic right now, both in the EU and here in North America. And one of the slides that I'll be showing, I think, is appropriate for that question, because it shows the complexity and the cross-sector, cross-disciplinary needs that are required to bring a group together to think about all the different aspects involved in ESG disclosure. You need attorneys, you need finance people, you need people that know something about ESG, you need researchers and technical programmers, you need marketing, you need HR, right? This is what companies are faced with right now. And I mention that because there are some folks maybe looking for jobs. We need all of your expertise, not just at Geosyntec, lots of other consulting firms looking for people right now. And a university like this, which is so broad, is a great place to develop those. So it's a two-pointed comment. One, if you're interested, let me know. I'm not gonna be able to stick around very long after because I have to get home to my family. But the university, talking to some of my Carlson colleagues here, needs to continue to innovate to make sure that you're developing the next generation of folks that are going to be able to not just do the research and stay in academia, but jump into the industry side of things and do that work as well.
Thank you, Jeff.
Yeah.
And you can find contact information for everyone on our posters. Vipin, what is your call to action for early career researchers?
I would, again, building on what Jeff said, is collaboration is the key. This is the message that I give to my colleagues in computer science who believe sincerely that they have developed methodology that can solve everything out there. That is, they talk about this knowledge-free learning. And it's sometimes easy to get intoxicated. You know, you see ChatGPT doing so many things. Who could have imagined that a few years ago? But the key is that to solve real problems, you need collaboration between people who know the problem, who know the communities, who know the domain, and the people who are building this latest generation of algorithms that are so powerful that you could not have imagined 5 years ago or 10 years ago. So there are amazing technology that's coming up, but to realize the potential, you have to collaborate with people who are trying to solve the problem, or boots on the ground.
Thank you. And Sam, I would like to give you the last word. What is your call to action for people early in this field?
Thank you, Colleen, for that really important question. I'd encourage all emerging scientists to look next to you and see who is in the dialogue with you as you're modeling and engaging around the complex future you wish to create. I'd love for you to look into the future and ask yourself, do we have the diversity of people next to us as we're practicing science and doing modeling in order to complexly enough model a future that's ecologically just? To pick on something that Justin shared from picking up Kate Rainworth's good work. And then I'd like you to look behind you and ask the question, how do I, as an emerging practitioner, practice a level of inclusion and democracy in the way that I'm practicing science? So it's less and less the norm every day that there's this disconnect between the people practicing science and the people who are most impacted by the limitations of science. So I believe that if emerging scientists practice that democratic intercultural process, that's a pathway towards an ecologically just future. So I want to be able to count on you to do that, but I also want you to be able to count on those of us in older generations to have your back as you take the risks of democratizing science.
Thank you for that incredibly inspiring last note. And thank you to all of you for your time to talk with us on this panel and this wonderful chat. And thank you to everyone for joining us.
Very inspiring day. We have the last segment, which is talking about early career. We have lightning talks to be made by some of our team members. So I'm going to go ahead and introduce. Yeah, so I'll introduce the 4 lightning talk speakers that we have today, and then we will be the end of our session. Because after the lightning talks, we have every refreshment or reception, whatever you do. It's been a long day. So first would be a video from Dr. Sunil Thakra, who is NatCap TEEMs scientist and served as a postdoctoral associate in the Department of Applied Economics.
here at the University of Minnesota. So Sunal sends this presentation. We really hope to be here because he's in the UK at the moment. So Sunal's talk is about modeling air quality health effects. So we can try to play that in the next slides.
Hello, apologies I can't be there in person. I'm Sunil Thakrar. I'm currently a postdoctoral associate at the University of Minnesota. I'm going to talk briefly about our work on modeling air quality health effects and how this fits into what we're doing at TEEMs. So exposure to air pollution is the most important environmental health risk worldwide. It's responsible for millions of deaths each year, and it kills more people than malaria, car crashes, and HIV/AIDS combined. So when we think about air pollution, we normally think about fossil fuel combustion, right? Tailpipes and smokestacks. But my previous work, such as in this figure, highlights that many other sources are important. So there's a lot going on in this figure, but if you look at pollution from food and agriculture, so the green flow, you can see it causes around 19,000 deaths each year. Whereas pollution from power generation, so the yellow flow, causes only 10,200 deaths each year. This is just looking at human-caused air pollution in the US, but there are an additional 30,000 deaths or so from wildfires and biogenic emissions. And globally, there are a lot more deaths from non-fossil fuel emissions. So a lot of this non-fossil fuel related air pollution is linked to land use decisions. And as we know, land use is a major driver of global change and has all sorts of impacts. So a question we might ask is, does considering air quality lead to better land use decisions, and how important are these effects? And to answer this, we have to model the effect of land use on air quality. So we want to take into account both the emissions, so things like dust, agricultural emissions, biogenic emissions, such as those from trees and other vegetation. And we also want to take into account the extent to which land use can remove pollution from the atmosphere. For example, filtration by trees. And then we need to jointly estimate air quality health effects alongside other large ecosystem services, such as carbon sequestration. This is because we want to know how big air quality is relative to these other ecosystem services. And because these are all in different units, so you've got health on one hand and carbon on the other, the only way we can compare them is to value the effects in dollar terms. So we did this study, so we looked at a set of trends and policy decisions related to land use out to 2050. I'm going to quickly go over 3 findings. So the first is that there are trade-offs between air quality, carbon storage, and economic returns to land. You can see here across the different trends and policies, this red bar is the change in value of air quality health effects. And the other bars are pasture, crop returns, timber, and carbon storage. And you can see just how large the red bar is. It's often larger than the other bars combined. So air quality health effects are really important. When you add those bars up, you can see that considering air quality health effects makes a huge difference to our overall preferences. So here the light gray bars show the total change in value from the policy decisions when we don't include the effect on air quality. And the dark blue bar is when we do include the effect on air quality. And you can see that our rank ordering of policies changes, and so does our understanding of whether the policies will make us overall better or worse off when we include air quality. And finally, in this example, we find that agriculture is a major driver of land use related air quality effects. So I should say this analysis is just for the US, and it also doesn't include the effects on wildfire risk just yet. So this was published in ES&T earlier this year. And as I mentioned, this study is just for the US, but the air is much cleaner in the US than almost anywhere else around the world. However, most of the global air quality models are very computationally intensive, which makes a lot of modeling attractive. So a couple of years ago, I and my colleagues developed the first global reduced complexity air quality model called Global InMap, which is high resolution, it's open source, and it can run on a desktop computer instead of a supercomputer. So now what I'm doing as part of TEEMs is a lot of global modeling. So I'm building a global land use emissions processor that can estimate pollutant emissions from agriculture, soils, land clearing, biogenic emissions, dust, wildfires, etc. And also pollutant filtration by vegetation. So this looks sort of like an inverse model, and indeed we hope to be able to incorporate it into inverse modeling so we can jointly estimate air quality health effects alongside other ecosystem services. We're also doing similar work to include air quality health effects in our global estimates of gross ecosystem product, or GEP. And finally, we're connecting air quality health effect modeling to economic modeling, looking both at how economic policies affect air quality and also how air quality health effects feed back into the economy. So some quick conclusions. So exposure to air pollution is the most important environmental health risk. A lot of that pollution is from natural emissions and emissions tied to land use, but it's often neglected, right? So people who care about land use policy seldom think about air quality. People who think about air quality policy seldom think about land use. And at TEEMs, in my opinion, we're at the forefront of incorporating global air quality models into other models looking at land use, ecosystem services, and earth economy links. And we hope that this will be a crucial step towards making better decisions that improve our health and well-being alongside protecting nature. Thank you.
Okay, so now we have three students, so PhD students, two are PhD candidates. Yan Chu will be the first, and then we have Ryan Markway, and then maybe Kulan. These will be the three speakers on the so thank you.
Hello everyone, I'm Yan Shulang. I'm a PhD candidate in applied economics, and also mostly importantly, I'm a team member. So it's great pleasure to talk this project. It's about poverty elevation and forest conservation in China. So human intervention are the main drivers of forest cover changes, particularly through agriculture, urban expansion, and infrastructure development. With the environmental goodness curve hypothesis, helping people out of poverty can reduce their reliance on natural resources, leading to positive effects on the environment. So for SDG 1, it's no poverty. China declared no extreme poverty in 2021. To achieve the no poverty or no extreme poverty goal, China took a company-based strategy to do poverty elevation. Importantly, in 2011, more than 200 companies were newly designated as the poverty companies. These are some criteria. What's the meaning for the poverty company? That means if they join the program, they can get a lot of resources and funds to do poverty elevation program, like relocation from the mountaineers every year, job skill training and village road construction and other programs. And here is the graph to draw the extreme poverty rate and the forest cover in China in the first decades of the 21st century. You can see the extreme poverty has been decreased a lot until 2020, and the forest cover actually increased during this period. So my question is, what's the impact of poverty elevation on forest conservation? So I collected several data, including poverty county data, forest cover data, and social economic data, and also reforestation data. For the forest cover data, I use a 30-meter China land use cover data stats. So here, this graph is draws the forest gains and loss in treatment and control groups during this decade of 2011. You can see most forest gains in China happened in the treatment group, that's the poverty counties. And the control group, they are the rich poverty, they have never joined the program with the red boxes. So here is a summary table. The most key thing, I mean, for the treatment group, they have higher forest cover but lower GDP. And I following the recent very popular method. It's called the difference in differences method to estimate. My treatment is participation into the poverty county program. So here is the baseline results. My outcomes of interest forest cover and also forest cover, including reforestation. So with the different fixed effects and the different controls, I found very similar and significant results. So after that, I did a event study just after the treatment in 2011. You can say actually in the first almost the full year there is no significant effects in poverty counties, but after that we can say a very big increase on forest cover in poverty counties. I mean, for the first full year, I can say since trees they need some time to grow up, so we didn't see some very significant effects. So you must wonder what's the sources for the forest gain. Here is the graph for the total forest gains in poverty counties. Most is from the cropland. That means so the poor people get some non-farm jobs. They are not rely on the cropland, and the original cropland were converted to forest. So here is my conclusion. I found an average annual increase of 0.7% in forest cover after the implementation of poverty elevation policy. And the results align with the literature in China and other countries. And given the evidence from the study for the future policy, I do recommend to integrate ecological restoration efforts and the poverty reduction program. And for my future research, it's easy to link poverty elevation, forest cover increase, and ecosystem services. That's the Earth economy model. Thank you so much.
Can everyone hear my voice? Yep. Great. I'll put on a timer so we can get out of here and drink the beer. Alrighty. So my name's Ryan McWay. I'm a third-year PhD student in the Applied Economics Department and hopefully a member of NatCap TEEMs. So thank you all for supporting it. My work is going to be a lightning talk. So this is my proposition of what I want to work on, not a result. So I want to look at the difference between pesticides and pollinators and the trade-off in agricultural production. So to give you a bit of motivation, about 80% of flowering plants need some sort of pollinator. And 80% of the plants that are pollinated by honeybees. That's about 130 crops. That's about $200 billion every year in value. But a third of those crops require some sort of pesticides. If we don't have the pesticides, we'll have a massive drop in fruit, vegetable, and cereal production. So within this context, two major pesticides, and I'm going to get this wrong, neonicotinoids and fipronils, are very popular amongst farmers, and this leads directly to bee colony loss. So clearly there's going to be a trade-off here. I need one input, which is the bees, and on the other side, I need pesticides. So at some point, there's going to be some loss in my crops, and it might be related to the pesticide bans. So what I want to look at here in this research is what happens when you ban pesticides in the short run for like an immediate harvest, and in the long run when I'm thinking about production over several years. In this context, the EU made one of the only credible pesticide bans that's actually stuck, where we can't see residue pesticides in the groundwater, in 2013. What this did was it limited neonicotinoids in the EU, but the thing was those production of neonicotinoids was still allowed to be exported outside. So this effectively increased the supply internationally of pesticides and should reduce the price of pesticides globally. A lot of developing countries rely on imports of pesticides, so they're very sensitive to the international price of pesticides. Now, honeybees are not our only pollinators that we can think about. So it's not just that if the honeybees go away, we have no inputs on pollinators. We have substitutes: hoverflies, blowflies, ants, houseflies, ladybugs, etc. So they could be providing some inputs to our crop production if we're losing honeybees as a result of pesticide use. So there is some substitutability of inputs in production. Because of my limited time, I will just gloss over this. The basic idea is you have a household production function. And in that household production function, we can either think of it myopically over one harvest or in the long run over several harvests. And there can be some arbitrary distinction of a policy where we say that the pollinators have to stay above some arbitrary level P, or else we're in violation of that policy. The idea of the model is to capture three main things. One, you have trade-offs in agricultural production that increase due to pesticide use and could reduce to agricultural loss if we lose the pollinators. The second is to illustrate that to maximize production, you have a different decision-making in the short run versus the long run. And the last is to show that the behavior of the farmers is critical for understanding the implication of pesticide bans moving forward at the global level. In terms of use, the data that I have pesticide use, imports, and exports from the FAO. For Tanzania, Ethiopia, Uganda, Nigeria, Niger, and Malawi, I have household level data over a panel from 2010 to 2020 of household behavior by the farmers, their production, their pesticide use, right? So this is at the individual level. We can really see what the farmers' behaviors is changing. In terms of what is happening with the pollinators next to the area, wild bees in particular, and a lot of other pollinators are not migratory. So once we have a map of occupancy models, we know where those bee populations are and how they're affected close to the farms, which comes into the INVEST model, which is about NatCaps and understanding the value of those pollinator dependency relationships to agriculture. And finally, because we're looking in a developing context, state capacity is important, right? A lot of the countries that I'm listing here do have pesticide bans, but they are not in effect, right? There's plenty of evidence that when you look at residual groundwater, those pesticide bans aren't in use. So thinking about the capacity of the state to actually enforce these bans is important within this context. I'm down to 40 seconds, so this is my sprint. There is a fancy model that I'm using. The idea is to use this shift share IV where there's a change in the import-export prices before and after 2013, and there's different exposure to the amount of imports that your country uses in pesticides, and that changes the amount of individual use of pesticides that used on that farm. This is going to be E. This is going to change by the farmer and by the year. That E is going to determine through phi the amount of pesticide use that any farmer uses. And that farmer use of P, pesticide, is going to come through the coefficient beta, which will determine my yields. My proposal is to analyze this mainly in three different perspectives. One is the agricultural production. So what are we producing? Are we extensifying? Are we getting into new land? Or are we becoming more productive on the farms through different technologies? The second is what are we doing with pesticides and their pesticide use? So am I limiting myself to pesticide use crops or moving away from them? And the last is what is the relationship between the pollinators and the crops? So am I moving away from pollinator dependent crops? Or am I intensifying a pollinator dependent crops, but still killing the pollinators right next to my farm? The idea here is that this is thinking about adaptation, right? Where the adaptation of the farmer in response to policies that are meant to handle a global issue, the extinction of pollinators and the loss of bee colonies. The efficacy of policy is going to be really important to understanding this because when we tell governments to do things, we want them to do it. So to understand when you have an ineffectual government is important. And the last is to think about the substitutability of pollinators. Maybe this is a problem that doesn't exist because you have other pollinators as inputs and the death of the bees is fine so long as you have a diverse body of pollinators near your farm that will provide for things where they're not affected by the pollinators pesticide relationship. That was me very quickly. Thank you for your time. I appreciate you all.
Hi, everyone. My name is Libby Kula. I am a doctoral candidate in the Department of Applied Economics. I'll also try to keep it very brief. So my project is titled How Equitably Are Ecosystem Services Distributed in U.S. Metropolitan Areas? So my project, the kind of nexus of it is in environmental justice and distributional issues within that. So when we think about distributional issues and environmental justice, I think of it in these two branches. On the left, we have worse environmental costs or damages going towards low income, Black, Indigenous, people of color, and other communities. And on the right, in green, we have fewer environmental assets or benefits going towards these same communities. So the left, I think we hear a lot about. Examples of this are disproportionate exposure to pollutants or climate change effects, natural disasters, and vulnerabilities. On the right, I think we can split this off further into inequitable ownership or accessibility of natural capital. And where my project primarily lies is in inequitable distribution of ecosystem services, and measuring that and the kind of distribution of environmental benefits, ecosystem services, or nature's contributions to people to different groups. And these are, of course, kind of all linked, but kind of the accessibility, the placement of natural capital will naturally impact the distribution of ecosystem services. So the motivation for this project: to date, most research on nature's contribution to people has been done for rural areas. It makes sense. These areas provide a lot of services that are necessary. However, since the majority of people live in urban areas, these areas, the ecosystem services that they provide are important to a lot of people's livelihoods. There is a literature on inequitable green space in urban areas, but there are few studies that quantify the economic gaps in nature's contributions to people or ecosystem services to different groups that arise from this. And most of these are case studies. So I pull on one case study in the Bronx in New York here. So talking about the workflow of my project, I run the Urban Invest, urban cooling and urban nature access models for all 380 US metropolitan areas. These models, Urban Invest, obviously part of the Natural Capital Project. And this is also going to guide my work assisting on the Global GEP project, working on urban cooling. So I do this for 3 years, 2001, 2011, and 2021, to be able to see trends over time. I aggregate the results to the census tract and merge with socioeconomic variables from the decennial census and the social vulnerability index. And finally, I perform my equity analysis in a number of ways. So I've just pulled up the Minneapolis, St. Paul, Bloomington region here as an example. So the Urban Invest results are spatially explicit. So on the left, this is a map of the Twin Cities metropolitan area and the different degrees of cooling occurring there. And on the right, I've included a bar chart of energy savings per capita going towards, in blue, census tracts that are above the median percentage of people of color in the Twin Cities, and on the right, those that are above the median percentage white. And you can see there's a sizable gap there. That's consistent across the entire United States, and the provision of services overall is going down over time. So the gaps tend to persist. This map is showing the relative size of that gap in average energy savings per capita between those above and below the median percentage of people of color for a metropolitan area. So this is the map in 2001, 2011, and 2021. We see it's incredibly persistent. There is slight change, but overwhelmingly there is this gap occurring between white and majority, or sorry, and relatively high POC percentage tracts. So in conclusion, I combine spatially explicit models with socioeconomic data to show which populations are underserved and what kind of investments and where would be most important to close these gaps. So thank you all. That is all.
We're ready for the reception, but first would like to close this session by thanking and recognizing all the efforts that went into organizing this event. So Terry over there, department head, and all of the organizing committee, that supported the planning process. I would like to take the opportunity to say thank you. We really appreciate the effort. And if you were in that group, please raise your hand to be recognized. Anyone who volunteered today before the event, thank you. Well, I would like to also thank Steve and Justin for coming up with this vision to create this center in the Department of Applied Economics. And thank our guest speakers, Mary, Becky, Tom, and the panelists, Vipin is here, Ken, Jeff, as well as Sam, for a very inspiring conversation about how we can work in this space and push we should work there. So finally, I would like to thank the audience, all of the participants for coming. This would not have been possible without your attendance. Those of you here in the room and those online, it's been a great moment to share. I think this is a historic moment in the calendar of the University of Minnesota's work on natural capital accounting, specifically on economy modeling. So on that note, I think we are ready to have some food and wine and chat, network as much as possible. Thank you very much.